Okay. Is it a hump or a drop? What do you say? You've got to twist your words in every which way, because the model will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line, or does it curve? Some people don't clamp it, but that is absurd. We all know that the model dictates what you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain. It's your ball and chain. Conflating curvature with elevation change. Just got your local distance just out of range. That old key is gonna dictate everything that you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain, and it's your ball and chain. It's your decision defending the model position. You just don't know the geometric proposition. That old ball will always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. That old model affliction, it brings you so much pain. It's your ball and chain. And everybody knows that you've got the model affliction blues.
Works really good with this guitar.
Is it a hump or a drop? What do you say? You got to twist your words in every which way. We all know that the model dictates what you do. Well, we know you got it, the model affliction. Model affliction. Model affliction. Model affliction. model affliction blue.
And we are live. Welcome everyone. It is Model Affliction Monday. And have we got some good stuff? Well, not really. Model Affliction though. They're showing their affliction. We've found that this model affliction goes pretty deep, I think. I think most people have some sort of a model affliction. Now, that model could be anything. It just so happens that in order to find the model affliction, we've been, everybody that's listening to this or whatever, they obviously know which model has led has been the forefront of us finding about the model affliction. But it's sort of in the last few months, this has spread to, obviously, other areas. This overall affliction that people have. The affliction comes when somebody has an idea of something and the perceived knowledge that they have overrides what would be normal reasoning, and it just sort of stops the normal reasoning. You take over by some sort of dogma, but you're unaware of it being dogma until somebody challenges you on it. What we've found just recently is there is there's always been a problem, right, within certain models, but this particular one has shown its ugly head, let's say, more recently, because the advanced simplicity that we bring, the easier the argument gets, the harder it becomes for people to see back to the original problem. And this original problem at the minute is horizontal. It's just a straight line. Simple. But because, call it ECV, the way that nobody seems to be able to address the actual issue, modern day times, people can't do that. So slight deflection into another area. But the problem with when you use advanced simplicity to get to the simple, there's not many places to go away from that. It doesn't contain the initial simple problem, and you keep going back to it. Obviously, we are known here for the statement that level is horizontal, but that was just a vehicle, a guide to get there. The actual problem is the straight line. But the straight line within the conception of reality, and how the straight line can't actually be transferred to reality once you've taken on this certain model. It seems so ridiculous to even consider, but that's where the problem is. A straight line. And just recently we've had this problem, and it's come around because of the statement of perpendicular. I mean, it's a fancy word. It's a good word for word searches and stuff like that. Scrabble. But you've got to take that back to the Euclidean principles, and they are the foundations of, I say, mathematics, the real basic foundations. start off with a straight line, and then you obviously extend that to a plane. It goes through the many steps that I'm not so sure people want to be hearing, or people actually know, don't know, or are really bothered about. But the thing is that this straight line and the logic that derives the straight line has become, it's under attack. It's been wiped from the education system. People have not really required to be able to use this reasoning process, mainly because the story's been told that it's already been done. There are geniuses, Newton, Einstein. I mean, they've done it all. There's not really any need for you to do it. And for you to be able to do that sort of thing, you'd have to be some sort of genius. And normal people just aren't these geniuses. So there's not really any need for anybody to do this stuff, except for the fact that there is a need for people to be able to do this, to just so they can get through life and not contradict themselves, not have to worry about a state of confusion that's brought around through earlier teachings that you've just accepted. Yeah, see, Jackie says there in the chat, nowadays a line ain't straight, bent is level, horizontal is a circle, and everyone fully engrossed in clown world. Well, I mean, I can't say for the rest of the population. I do really want to talk to people about this, because I do fear there's more people out there that aren't really aware of this understanding that well, I don't know whether it's they don't know things or that they do actually know things, but they're too scared to contradict modern science or modern mathematics. People thinking that they're not as clever as they are. Yeah, Dinosaur Falcon. I feel a Dinosaur Falcon, right, in the chat writes, a horizontal plane isn't horizontal anymore. Only at a point is it actually horizontal. It's weird. Well, that's something you get into within this conversation. And I do really feel it's part of our problem. We've done that by saying that level is horizontal and not capitulating to the fantasies of this group of people that want to imagine something different. They want to imagine they're not that. Whereas, I mean, horizontal is a thing, but it's rapidly becoming part of a flat earth thing for some reason. I think we did hear today, we were listening to Red's Rhetoric video. Now, I don't know if anybody knows who Red's Rhetoric is. He used to be around a bit ago. He was part of the Fight the Flat Earth, Sean Huffraud. I don't know who else there was. There was quite a few of them, but they were known for being this certain group. Oh, Slice Parkane. He was a big part of that group. And obviously Jesse Kozlowski, Soundly. I don't know whether you call them the original debunkers, but I don't know what they were debunking. They were just taking money off people. So he disappeared after the big fraud thing with Sean Huffraud, and there was a big thing about them taking, I think it was nearly $250,000 in did he call them, go fraud me's and stuff like that. So Red's rhetoric disappeared, but then he came back a bit, like after a couple of years, and he's been hanging around. And he did a video today. He was meant to be doing a video, a debate, which he chickened out of, about spherical trigonometry, which there is a claim that spherical trigonometry is entirely Euclidean. Yet the Red's rhetoric was to say that it wasn't. So Mike Jones and Red Rhetoric were due to have a debate, or Mike Jones offered Red Rhetoric a debate on spherical trigonometry. Now, I'm pretty sure that in that video, the last video that Red's Rhetoric did, he's leaving, he's going. He can't debate Mike Jones about spherical trigonometry, but he did claim that horizontal is flat Earth now. It doesn't exist in reality, and anybody that says it does is getting called a flat earther. So I feel guilty for that. We're not flat earthers, yet we've managed to bring confusion around a term horizontal. And this has been highlighted recently by a guy called Beddy. Most people don't really know him. He's been brought in by the Blue Marble Science team to be their voice of logic. I don't know whether, did we have that? I think we've got a video that we might be going over for tonight, Model Affliction Monday, unless anybody wants to come in and have a word about anything to do with any of this stuff. You're free to come in. This is Model Affliction Monday. We will be going over a few things that are have come around because of the model afflicted. There's a guy called Flat Earth Math. He's been around for quite a long time. Now, he says he's not a flat earther, but I mean, that's a bit hard to say you're not a flat earther and be called Flat Earth Math. You've got a bit of a nerve to be able to try and fool people with that. I mean, it does go along with the contradiction, right? You're contradicting yourself using flat earth, which is an oxymoron, an impossibility within itself. So using that term and then saying you're not a flat earther and calling other people flat earthers that say that they can prove it's not a flat earth. This whole arena is becoming a bit of a joke, to be honest, to anybody that's listening in. And I think that's the idea. I think people, modern day times, within this arena, they don't want clarity. They don't want to find a discussion where you can both learn from each other. They'd rather call names and then obfuscate because, I don't know, modern day, hey, 2023. Don't know where it's going. It's a bit hard to work out what is happening. So I can't remember where we looked at. So can I get this? It all came about because of a logic statement said by, but I've posted loads of pictures on here now since. Give me a second. I don't know where it is. Flat Earth Math. You. I got it earlier, didn't I? Oh, does anyone know where it is? I probably had it. I posted it earlier. I can't find it. Oh no, there you go. Okay, so this is here it is in the screen. You've probably heard it, but following on from this, normally comes a problem. I mean, this guy says a problem. Now, I don't particularly think there's a problem. Did I not? Okay, so let me see if I can get this other one. Because I took the longitude and latitude out because it's a little bit tricky for some people. Oh. There you go. Right. That one's better. So this argument done by Beddy, I've just took out the two words there that I consider them to be irrelevant to this argument, but we'll call this the perpendicular. This is Beddy's perpendicular argument. And he says, let's spell this out. A is perpendicular to B. This is line A, perpendicular to line B. Two lines, e.g. of A. So you've got two A's, and they're going to be perpendicular to the same line, B. So two lines perpendicular to one line. He says they are parallel to each other. So the two lines that are perpendicular to the one line will be parallel to each other. He says, therefore, logically, all lines of A, that would be the line that's defined as being perpendicular to the other line, all of those are parallel to each other. Do you agree? He says, I think you do, because you have used this line of reasoning many times. Well, it's a perpendicular statement. So if that's the thing that you're laying out, that if A is perpendicular to B, then all A's will be parallel to each other. I mean, that makes sense to me. Mathematically, geometrically, does make sense. And he says, chorally, that means without any extra information, you can derive something. He says, because parallel lines by definition do not meet, the lines of A, the ones that he's already stated as being parallel, do not converge. So parallel lines by definition don't converge. They don't ever meet. Then these lines of A that are perpendicular to B, they don't diverge. So therefore, they're parallel to each other. He says, please answer the question, do you agree or not? Well, it's a standard perpendicular thing. It's through mathematics. I mean, yes, I do agree with the perpendicular logic that Beddy has laid out. Now, you could place other things in there for A and B, but in order for you to have this relationship of perpendicular, you'd better make sure that A and B are perpendicular to each other, because this is perpendicular logic. derived from our friend Beddy, who is one of the blue marble scientists. He normally does a dictation sort of thing where he comments on all of this. So this is his logic. Now, there comes a problem within the minds of certain people, because while this works perpendicular relationship of A and B, because they're lines and obviously they're perpendicular, so they're straight lines. So this works when you do that and you have lines that are perpendicular, like, say, for instance, vertical and horizontal. They're two lines that are perpendicular to each other, so they could fit in here. And as you can see, originally Beddy said longitude is perpendicular to latitude. Well, are they? I mean, many people probably, you might know that vertical and horizontal, you've heard those being perpendicular, so they can fit in. What about longitude and latitude? I mean, I have heard that longitude and latitude are perpendicular to each other. I've heard that from quite a few people. I've never heard anybody that said they're not, I don't think. But I don't know what Beddy was trying to get at with the original thing, so that's why I put the A's and the B's in. But the problem comes when you have people, I think it's these flat earth people, or flat earth math, who, you see, he does this. I say, place them in Beddy's perpendicular argument, see what happens. And he says, that's ingenious. That's a perfect analogy. If you start with horizontal, then you can't guarantee different lines will be vertical, even if they're perpendicular to the horizontal. Now, he uses horizontal in bunny ears as though it's a spoken word. Normally said to signify the not that. So he's saying horizontal, but he's putting bunny ears around it, which means not horizontal. So I like, again, this is flat earth math, so he's allowed to be crazy, because, I mean, flat earth math doesn't actually exist. So this is what you've come to expect from anybody that's called flat earth math. He says, then you can't guarantee different lines will be vertical, even if they're perpendicular to the horizontal. Likewise with lines of longitude and parallel. Thanks for pointing this out. The reason why both break down, horizontal and vertical, and lat and long, is that neither set of vocabulary terms are defined within Euclidean geometry, and both require an earth to make sense, thus are dependent on its shape, says Flat Earth Math. He did make a video over the weekend that he went over this sort of stuff. Here's another one. He says, this is the same guy, Flat Earth Mathematics, Flat Earth Math. Latitude and longitude are perpendicular, he says. So to me, perpendicular is a mathematical statement, meaning straight lines that are at right angles to each other. Two straight lines having a relationship of being at right angles to each other. They are perpendicular, says Flat Earth Math. Always. Always. But Beddy's trying to get you to realise the futility of saying two longitude lines, both perpendicular to the same line of latitude, have to be parallel. The futility of saying that they're parallel, even though they are perpendicular to the same line, and this is what Bedy's logic says. If they are perpendicular to the same line, then they have to be parallel to each other. And Flat Earth Math says that Bedy's trying to show us the futility of having a mathematical, logical statement about perpendicular.
I would say that this is misrepresentation what Bedy stated.
Probably, yeah, but this is Flat Earth Math, right? This is the misunderstanding of Flat Earth Math around a simple, logical, mathematical statement. It's shameful, really, but I mean that's what we're highlighting tonight. This is the way that somebody who's admittedly never done any logic yet calls himself an expert in geometry. Self-proclaimed expert in geometry, claiming that Bedy, the self-proclaimed logician, is trying to show us a futility of a logical statement. He says, both Bedy and I know they're not parallel, even though they are perpendicular to the same latitude. What do you reckon to that? I mean, that's a big claim on the behalf of somebody who he's not talked to about this. I don't know whether he can actually come and show this. And let's say Bedy's not going to come and go against Flat Earth Math, because, I mean, he's Flat Earth Math. He's got Flat Earth in his name. You don't go up against somebody who's got Flat Earth in his name whenever he comes and wrecks your logical statement. So, I mean, we'll go over it again. Bedy's logical statement. A is perpendicular to B. Two lines, e.g. of A, perpendicular to the same line, B, are parallel to each other. Like, that's what Bedy says. Two lines that are perpendicular to the same line are parallel to each other. We'll just go back down here and it says, but Bedy's trying to get to realise the futility of saying two lines both perpendicular to the same line have to be parallel. So according to Flat Earth Math, this statement here that seems like a logical statement
is futile.
Is futile, right? He's trying to show us the futility of writing out a logical mathematical statement.
Okay, but he is not denying that this statement is true. For me, this is just like psychological game, because it is irrelevant if it is futile or not futile. This statement is true. So how someone would use that in futile way or not futile way, it depends on that person. But still, this statement is true. So saying about futility or not futility is just irrelevant here.
Yeah, but he does say, he says, both Bedy and I know they're not parallel, even though they are perpendicular to the same latitude, right? So Bedy's writing out a logical statement saying they have to be parallel if they're perpendicular to the same line. And Bedy and Flat Earth Math saying Bedy knows they're not parallel. So
well, this is contradiction, and better for Charles to speak for himself, because I would love to hear or to read that from Bedy himself, because now Charles is speaking for Bedy.
Yeah,
but this is obvious contradiction, because
I asked him if he has talked to Bedy, and he said no. And see, Charles, Flat Earth Math, has told us he's never studied any logic. So without knowing Beddy and without talking to Beddy, he's saying that Beddy has formulated a drastically wrong formulation when it seems like it's a truthful one, right?
Not seems, it is. It is.
Well, I mean, you've got to give him a bit of chance, right? I mean,
Okay, it seems like,
yeah.
okay.
Yeah.
For now,
like
today.
You could check it and you might have already checked it, and I could check it and I might have already been able to check this to see whether it's true or not. But it's pretty obvious that Charles hasn't checked this, or he hasn't checked it with Beddy.
Okay, so
Beddy's in the chat. Beddy says it's interesting.
Let's give him benefit of the doubt. Okay.
Let me just move this over so Beddy can actually see it, because there you go. Right, so what's Charles say? He says, I can't talk now or even text, even though he is texting now. Working on my house. Please quote Beddy accurately. He did not make the statement with lines A and B. His statement was about lat and long, but I mean, it was about perpendicular. The logic was about perpendicular. Is that right, Beddy? Your logical statement that you wrote here with longitude and latitude, we could call A and B, and it's perpendicular logic. You could write in vertical, horizontal, they're both perpendicular, so the logic would stand, because that's all we're bothered about. We're not bothered about the item A or B. It doesn't really come into the logical statement, because we are talking mathematically if A is perpendicular to B. Charles says, we haven't quoted that right.
You have just read this, so.
Yeah, how could you be quoting it incorrectly? I mean, it is Beddy replying to you, and those are, I presume, Beddy's words.
Yeah, those are Beddy's words in that. I just took the latitude and longitude for people that don't know what latitude and longitude are and simplified it. Advanced simplicity. It's an argument, okay. Beddy's perpendicular argument. It is. Beddy says it's not a logical statement. There's no logical statements in here, according to Beddy. It's just an argument. Now, Beddy, do you believe that your argument, your perpendicular argument, is a truthful one? Do you believe it stands with A is perpendicular to B? Because we've got flat earth mathematics here that says he did not make the statement with lines A and B. His statement was about lat and long, but it was about perpendicular.
It doesn't matter how you label straight lines. You can call them whatever you want, A or B or latitude or longitude or whatever else you want.
The concept of perpendicularity is very clear, is it not?
Absolutely.
Or maybe it's not.
Definition
maybe it's not.
10.
Maybe that's
In
what we're
Euclid.
finding out here.
I don't know. It's up to you, Beddy. What do you think? Did you write your argument with the intent to fool people? Or did you write what you call a sound argument? Does it hold the truth value consistently all the way through? Because what I would say, right, I don't like the way Beddy writes it with 1, 2, and 3. I would say if we make it an if-then statement, we could say if A is perpendicular to B, then two lines, both perpendicular to the same line, will be parallel to each other. That would be an if-then statement. And would that agree? Betty says it's not sound, but it is valid. Perpendicular logic. It's not sound. Wow. That's Betty for you.
Is it true?
That's interesting.
Is
Yeah.
it true?
Betty says it's not sound, Paper.
I don't know what sound means because
It
he's
is valid,
using
though.
this.
It is valid. It's not sound, valid.
Still, I don't know what sound means in his mind, because if it is valid and is true, then everything is okay.
Mhm.
That's my question: is if it is true, not about soundness. I am asking about truth.
Can we get a ruling from Betty?
The truth. Does the truth value, is that maintained right through it? Oh, apparently we're using the wrong terms, right, Betty? This is your logic. This is your logic. And there is a problem that's going to be coming up quite soon. So the perpendicular, is it true that if A and B are perpendicular to each other, then two lines of A that are perpendicular to the other line B will be parallel to each other? I consider that a true statement. Betty might want to use different words for true. What do you call, Betty? What's the word that you use to show that the truth value is maintained throughout the entire argument? Because we just use the simple words. True. It's a true statement. It's not his logic, even though you were the one that wrote it out. It's like, that is your writing. You did write it out, Betty. The logic that you wrote, Betty, is that true? Does it maintain the truth value for the perpendicular argument that you wrote out, Betty? I don't know how much simpler I can make this.
In that case, true value would be that conclusion. So this then or therefore is inevitable conclusion, and it has to be true, because inevitable conclusion has to be true.
Truth preserving, Betty wants to call it now. Right now, Betty, okay, we'll use your words. The argument that you wrote out, Betty, about perpendicular, right, is the truth preserved throughout the entire argument to come up with a conclusion that is true? She's even telling us what I meant to say. I know what I meant to say because I said it, Betty. The problem is you don't seem to be able to answer. Stop telling me what I meant to say and answer the question. It's your logic. You wrote it down. Do you believe it is true? Not my words. You wrote them down, Betty. This is what we call ECV. The argument is valid. Now, does valid, Betty, does that mean that the truth is preserved entirely through the argument? Is that what valid means to you? Because there'll be people that don't know. Most people understand truth.
And in addition to that, if Betty said truth preserving or whatever he said, where does sound fit in? So you have valid. I know he has said sound as well. Yeah. And now there's truth preserving. So apparently there's three. I'm interested in this logic as well. Three
Oh,
parts
wait a
of a
minute.
logical argument.
Betty says this is from a textbook, so he's copied some logic from a textbook. Anyone think that the textbook would have had some wrong logic in, or do you think we can say that because it's from a textbook that Betty didn't, that he copied and wrote out? Is that valid, Betty? Valid equals truth preserving. So he's taking us, running us through it all now. So Betty does think it's true right now. This is the problem here, Betty. Charles says that they are perpendicular. So the antecedent is confirmed to be true. So modus ponens, we've affirmed the antecedent. But, Betty, here's the problem. He says both Betty and I know that they're not parallel. So he's denied the consequent.
Yeah. And
This is why
contradiction.
Yeah, it's you've got a modus tollens and a modus ponens, but as we know, when you deny the consequent, you also deny the antecedent. But Charles has affirmed the antecedent and said that you've affirmed the antecedent too. I think he's a little bit struggling. That's Charles, that is. But I mean, it seems like Betty, he seemed to say that you know that too as well. So although you say that the truth is preserved all the way through, Flat Earth Math, Charles, is saying that you don't think it's valid. That's the problem, I think. Don't, please, Mike, please do not let Betty get it off somewhere.
Yeah,
Let's keep him on this, because Charles has said that Betty knows they're not parallel, even though there is a consequent of them both being perpendicular to the same line, that they are parallel. Betty, there's your problem. We got any answer to that? Are you going to just ignore it now that you've opened up this argument for Charles to not quite understand? We have got a video that we can go over where we talk to Charles about this very issue, and he says that you are trying to falsify, well, I guess in this, for the understanding of this, what would have to happen in this case? Would Betty have not have to have set up a sound argument, or is Betty actually trying to undermine the Euclidean statement that allows him to make that statement, or that logic, how it allows him to copy the logic from the textbook that he got it from? Perhaps it was wrong in there. Perhaps the intent of that was to undermine Euclidean geometry.
Yes, they want to have this perpendicularity, but they deny consequence of that, which is in that case parallelism. And you cannot do that. Just deny parallelism without denying perpendicularity.
Mm. Well,
but they want that. They want that. They want to hold perpendicularity while denying parallelism. It is impossible.
Yeah, but this is what Mike put. Mike wrote in order, to talk to Betty. He said, in modern logic, a sound argument is a type of logical argument I don't know what one of those is, Betty. Is that, you sure that's all right for him to break that? Type of logical argument that is both valid and has true premises. True premises, that is.
Yes, but maybe before wrote that sound means true premises. So he is not talking about premises and conclusion. And you were asking about the whole argument. Is preserving truth in whole argument? And Baby's answer was that sound means
not sound.
True.
No, he said it earlier, in the little bit that he put earlier, it's not sound, but valid.
Yes, but he says that sound means true premises, not conclusion. He didn't say that.
Which means that if he says it's not sound, that he doesn't think the premises that he wrote down were true. Right? If Beddy has said he does not consider that a sound argument, then the premises that are wrote down he doesn't consider as being true.
In that case, yes.
But the premise would be, premise one at least, that longitude and latitude are perpendicular, which flat earth math says is true.
Yes. So, yes, they want to have this premise be true, and they want also to deny consequence of that, which is parallelism. So they have a dilemma.
So which bit isn't true then, Mike? Betty? Which bit is the bit that makes it unsound? Because flat earth math says they are perpendicular, and as we know, two lines that are perpendicular to another line will be parallel to each other. That's a true statement too. So if Beddy doesn't think one of them isn't true, which one's that Beddy doesn't think that's true? Certainly not the parallel bit. This is the bit where Beddy disappears now. Because Beddy's wrote this logic from a textbook. Do we know which textbook? Beddy, did you copy it out directly? Was it longitude and latitude in the textbook? Beddy's showing us an unsound argument. He doesn't agree. All right, he does not agree with the argument he presented. So he got an argument from a textbook, and he's showing it us because he doesn't agree with it. But it is an argument about perpendicularity. So Beddy doesn't agree with the perpendicular logic that he's wrote down. That's another one. That Rumpus said that, Beddy. Do you agree, Beddy, that you don't agree with the perpendicular logic that you wrote down? Any textbook.
Does Rumpus represent you well?
And Charles as well. Charles is also speaking for Beddy. It's like anybody can speak for Beddy on the matters of logic. I mean, they must know more than he does. Or they must know that he doesn't really know that much. He's just copying stuff out of textbooks that he doesn't agree with. Or, well, that maybe they were wrote as a bad example of an unsound argument in a textbook that Beddy decided to copy for us.
For me, it doesn't matter. Sound or not sound, it has to be true and valid. And valid means also formally correct. So formally correct and true.
Rumpus is speaking for Beddy. See, there's no need for you now anywhere, Beddy. Go on. Rumpus can do all of this sort of stuff. Just hand Rumpus the textbook and he can sort it from here. who needs aporia anyway? So the problem is that with the argument that Beddy brought, what they want to do is they want to affirm the antecedent and deny the consequent. Is that right, Beddy? Or do you want to deny the antecedent and deny the consequent? I'm a bit struck as to what you want to do with the perpendicular logic.
What did the textbook tell him to do? That'd be interesting.
He won't tell us that, whether the textbook was writing unsound arguments, like an example of unsound arguments in the textbook.
Surely the shadow giants know what to do with this conundrum.
Well, I think it's one of these cases. When I first came into this, I came into this with an understanding of surveying. And I knew right then that there would be nobody that could come up against an understanding of surveying. So therefore, anybody in this arena can say anything they want. And nobody will ever come in with an understanding of surveying. We're much in the same position right here, right now, with logic. Because I believe there's a group of people that are trying their hardest to purposely not understand logic. They can't understand logic. Logic is something that they are averse to because they have a model that's built entirely upon contradictions. And any sniff of logic will show these contradictions, much like we're seeing right now. This logic proves that the mental state of a group of people. But he's laughing at affirming the antecedent and denying the consequent.
The Rumpus' defense of baby is just ridiculous.
Antecedents and consequence are not part of this argument.
It's just worth clipping here because this is beautiful.
Let me get that. And even Beddy sort of sticking up for Rumpus. He's laughing at affirming the antecedent and denying the consequent.
This is what flat earth math is doing. He's affirming premise or antecedent and denying the consequent at the same time. And he is saying, flat earth math, that you, baby, are in agreement with him.
Mm-hmm.
So we just asked, is it true that you agree with him on that? But you are laughing, so it means that you don't agree with the flat earth math. So you don't do that stupid thing like affirming antecedent and denying consequent of that antecedent. Yes, that would be stupid. So you disagree. I take it as disagreement.
Yeah, that is a fallacy, right?
Yeah, this is just nonsense.
Rumpus. Well, the antecedent of this particular thing, Rumpus, is that A and B are perpendicular. And the two lines of A perpendicular to the other line B, they are parallel. The consequent is that they are parallel. So the antecedent is if two lines that are perpendicular to the same line, antecedent, the positioning of two lines perpendicular to another line, the consequent is that the two lines that are perpendicular to that other line, that will be parallel. Antecedent, consequent. Rumpus. Now you can either affirm the antecedent, which will affirm the consequent, or you can deny the consequent, which will also deny the antecedent.
Yes.
That's the way logic works.
And the first is modus ponendo ponens, and the second would be modus tollendo tollens.
Rumpus. I mean, there's beyond a joke, Rumpus, and I think everybody, like, there's got to understand now that you don't know what you're talking about, Rumpus.
I think that he reached the state of aporia. You know, I think maybe.
Yeah. Rumpus doesn't like that. Anybody else want to have a go at the antecedent consequent relationship within logical statements, arguments?
Antecedent is what is before. So, and consequent, it is in the word. Consequent, sequor means follow up. So we have something which happens.
Antecedent, that which must come first.
Yes, but we can't say that it was first because we have already the second. So something happens, and the consequence of this thing happening is something else, and this is consequent, which is following up the antecedent. So this antecedent is always followed up with consequence. And this is for me, this is so obvious, but it is in the word. Ante means previous or before. Antecedent, before something follows, it is antecedent. And then we have this thing which follows, which is consequent. It is going together with antecedent. So they are always at both. You cannot separate antecedent from consequent. They are both, always, forever.
I see Betty has gone quiet. I would. You carry on, Rumpus. Pretend Betty's with you, and you're now the leading logic guy, right? You've just said that two lines are perpendicular to another line, and then you're going to say, well, mathematically, then they are parallel to each other. Simple statement, but Rumpus doesn't seem to think that works. That's not how it works. Rumpus has become a logic expert. I wonder whether Rumpus knows the statement that Betty took it from. Should I think it was 28? Is that right, Betty? 28.
That's what he said previously.
Okay. If a straight line falling on two other straight lines make the exterior angle equal to the interior and opposite angle on the same side of the line, or make the interior angles on the same side together equal to two right angles, the two straight lines shall be parallel to one another. I think I'm pretty sure that's the one that Blue Marble used in his reciprocal.
No, he used 29, I think.
Did he? Oh, yeah. And the exterior equal to the interior on the opposite side of the same angle, and the two interior angles on the same side together. Yeah. Well, 28, that's what Betty used. Now, Rumpus, do you want me to do it again? I'll just state it again, just to make sure that this is what you think is unsound. If a straight line falling on two other straight lines make the interior angle equal to the interior and opposite angle on the same side of the line, or make the interior angles on the same side together equal to two right angles, the two straight lines shall be parallel to one another. He just did the two right angles, the perpendicular part of it, because you could both be leaning at the same angle, couldn't they? That's what that other one means. But apparently, Betty thinks that's not sound, and Flat Earth Math wants to affirm the antecedent and deny the consequent of a mathematical statement, proposition within Euclid. Welcome, Constance. Good to see you back. You can post a picture in here, Rumpus, if you want, but we know you can't do it. You can't talk about this stuff. What we've done, we've worked out recently how to make people disappear. Red's rhetoric's going. He can't talk about spherical geometry. Spherical trigonometry. He can't even talk about spherical trigonometry because that will expose the nature of spherical trigonometry. I mean, everybody knows he can't speak about spherical geometry, but he can't even talk about that. So he's having to run off. He's having to disappear. He's leaving again. He's gone. Obvious that Rumpus can't talk about any of this. Beddy, he's a logician. He can't even copy stuff out of a textbook without other people, Flat Earth Math, telling him he knows it's wrong. And in Beddy's even said he doesn't think it's a sound argument. So a textbook of unsound arguments. That's what Betty uses. No truth premises around here. Well, we did have a thing when Raven came round. Remember that? We did have a big thing about if you're doing logic, do you need to have truth in them? I would say, yeah, you have to.
I can agree with that, that you can have in textbook examples of untrue or incorrect syllogisms or arguments or whatever, because I have read one, let's say, manual of logic where there were examples of let's say unsound arguments, but I wouldn't say that this particular example with longitude and latitude arguments or whatever was in this textbook. I think that Bebe created by himself this particular example, and he thinks that maybe it is example of unsound argument. But I think he's giving wrong example here. Or maybe he thinks that this is an example from textbook or like analogy, analogical example about unsound arguments. But this is his argument. I don't think that this latitude and longitude example is in textbook.
I'll put a poll up there for anybody who wants to have a go. Are latitude and longitude perpendicular is the question. seeing we can sort out the first one, the premise. Perpendicular. Simple question, and then we can deal with the rest of Betty's argument to see whether Betty's perpendicular argument works. Make sure you get an answer in everybody jump on the poll. We want to know, are latitude and longitude lines perpendicular to each other, or have you been told that longitude and latitude? Go on.
Can I say something?
Yeah, who's that?
It's Rob.
All right, Rob.
Are they straight lines?
That's the question. Are latitude and longitude
No, the question was, are they perpendicular?
Yeah.
Well, in order for them to be perpendicular, they have to be straight lines.
Yeah.
But are they straight lines in their model?
Don't know. I'm not bothered about in the model. Like, what have you been told? Are they
Yeah.
perpendicular is the question.
They appear to be on most maps.
I think people can answer for themselves, can't they?
Yes.
Yeah.
On different maps, they are shown differently. On Mercator, they are straight lines, perpendicular. But for example, on IE projection, they are not, of course, because one of them is radial and the other is just a circle.
Ah, well, but see, this is where you get into it now, because flat Earth math thinks that a radius is perpendicular to the circumference.
Yes, I know. But this is, of
So
course...
are latitude and longitude perpendicular? Very simple question.
No, for me, still not, because radial line is not perpendicular to circumference.
All about what people think. And we can deal with Betty's perpendicular logic after that. Because I think the logic is valid for perpendicular. If you just say if two lines of A are perpendicular to another line B, then like grid lines in mathematics,
yes,
they are parallel.
This is pre-assumption. So if you are saying that latitude and longitude are perpendicular, you are pre-assuming that they are straight lines. This is inevitable. You cannot do that. So that's why I am denying perpendicularity between them.
Yeah, it
Because
seems
one
like
of them,
there's like a 3-to-1 split. 73% yes at the minute. So the general consensus at the minute is that they are perpendicular, yes.
Okay, I can destroy that consensus.
Well, I mean, this is where flat Earth math comes into it, because he would be on this side. Yes, they are perpendicular, but that would mean that they are also parallel.
Yeah, that would mean, yeah.
Well, the latitude lines, they are called lines of parallel, right? They're called the parallel. So could we say that latitudes are parallel? They are perpendicular to the longitude, and they are parallel. Yeah?
If they are, if it is assumed, yes. So with that assumption, which I reject, of course, but
well, latitude lines are called parallels, aren't they? Do you know, go to the such and such parallel? That's what they're called.
Yes, but my objection is that they are expressed in these longitude lines. Distance between longitude lines are expressed in degrees. There is no so how can you have degree between parallel lines?
Yeah, I mean, I'm not saying that they are parallel. I'm saying that they're called parallels.
Yes,
right
yes.
now,
So
the modern day seems to allow people to give them contradictions, or it makes contradictions. So in calling these lines perpendicular, you are saying that they are straight.
absolutely, yes.
And in saying that the latitudes are parallels, you're saying that they're parallel to one another.
Absolutely, yeah.
So
I
that
agree.
would be, I don't know, like it depends how you want to carry that through. If you think of them mathematically as being perpendicular, then as Beddy states in his logic, they are parallel also.
Yeah, absolutely, yes. So if assuming this premise is, or antecedent is true, the consequent has to be true. So absolutely, and that's why that's how you create modus ponens. So if someone is agreeing on perpendicularity in first place, he has to also confirm consequent. But I'm just denying antecedent, so as being untrue. But if someone is saying that they are perpendicular, it means that, of course, they have to be parallel. So
yeah, see,
you have to be consequent in your logic.
Yeah, well, you could say the same, right? If latitude and longitude are parallel, are perpendicular, vertical and horizontal, are they perpendicular?
Yes, yes. Yeah, I'm
plumb and level, are they perpendicular?
Absolutely.
Okay,
and
so there's
there's
three things that are claimed to be perpendicular that we could class as similars.
Yeah, I absolutely agree. So if someone is saying that they are perpendicular, it means that these longitude lines have to be parallel. Absolutely. But the problem is that flat Earth mass is trying to deny consequent. This is problem here.
Yeah, and this is why Beddy, nor Rumpus, nor Blue Marble Science, probably not Flat Earth Mathematics, he can't come in and do this either. Because it's a blatant fallacy. Quite obviously a fallacy. That's leaving them in a place of aporia, we were saying. Because it's in the middle. You're in the middle of a modus tollens and a modus ponens, stuck in no man's land. Nowhere to turn. You don't know what to do. That's the very definition of being in aporia, which Beddy is very good at. This is an argument that Beddy has brought around, a perpendicular argument, and he's landed it right in the middle, the heart of a group of people that are unable to explain how perpendicular lines end up with the mathematical consequent that they're parallel. The grid system is formed from this relationship of knowing that two lines that are, however many lines, perpendicular to a line will be parallel to one another. There's even an axiom based on this very thing, but it doesn't really state this. This is the one situation where the triangle isn't formed, and you can't tell which side of the line the triangle is formed on, because obviously the 180 degrees is made up of the two right angles. So that'll be the end of those guys. So now we've done away with the troublesome people that make the arguments. We can carry on with the rest of the show. Thanks for that, Blue. Was it Blue? Blue came in as well, didn't he? Blue, Rumpus, and Beddy. obviously Flat Earth Math, he comes in and has a chat with us. So I'm going to put a conversation we had about this very issue the other day. We were talking about the idea of perpendicularity. Actually, it came around the weekend, I think it was. We were just sort of I was tidying my kitchen, getting it ready, and we'd had a I don't know, was it UFC night? I think no, he came in to tell us on UFC night that he had a video out, and I think that's the video where he tries to say that you can have perpendicular radius can be perpendicular to the circumference. I think we go over it, although we haven't watched the video yet. We did watch the after show that he did, which was very good, Charles, if I must say. The fact that nobody talked about your video just goes to show how much of a state of aporia Betty has managed to place everybody in around this very statement of perpendicularity. It's a problem. I think Buster sings it in the Model Affliction Blues. Perpendicularity will always be a puzzle to you, I think it is. I think that's the line. Very true, it seems. Even when Betty tries to make his arguments. Okay, let me get this video on. And right, there we go. And so, like I say, Charles came round. I think I was probably playing a game. So I'll put this on. As always, let us know. This is about 1 hour 40 of a video. So, like, I don't want to be... I might skip through it, but, I mean, there is some good stuff in here. Like on Friday when we had Matthew Learns round. That maybe need going over because Matthew Learns is a mathematician. Thank you very much for the votes. We'll deal with this as we're going through this conversation.
Everybody.
Oh, yeah.
I think it was J. Rowe who invited me. How are you folks doing? I didn't get to hear most of today's show. I heard a few minutes at the beginning, but I was working on a project. So
Very low volume, I think.
Yeah, I don't know how to turn the volume up on this end here. Yeah, sorry, you're gonna have to can't turn the volume up at this end. Yeah.
Okay.
We're just hanging out.
Is that a thing that Jeranism or a comment on it? What do you think about the arguments going on in Flat Earth? I suppose you're right in that, right? It's like they're ending it. Or like there's only one true flat earther.
Who would that be?
Don't know. I don't know. They're all like trying to educate each other at the minute. I think it's much like our friend Flat Earth Mathematics here.
Hey, a mild change of subject. I just wanted to say this very quickly to Buster. The last time we spoke, you were talking about the two ends of the bridge and then the one in the middle, and then would I be able to find the distance in 3D space of the X, Y, and Z coordinates. And so I actually, I got the 2D part, and it literally took a page of algebra to derive a formula to find the distance from a point to a line, given 2 points. So I wanted to say that I definitely have made progress on your challenge. I haven't forgotten about you, Buster.
He's talking about Buster challenged him. I don't know, but I think it was about the Lake Pontchartrain Bridge, right, from point A to point B. I don't know why he was saying it was a challenge to work out how far it was from A to B. But again, that's what he's talking about. I can't remember what it was. I think he was trying to map what Walter Bislin did when Walter Bislin did his absolute geodetic software writing in order to come up with the original bendy bridge. He was challenging flat earth math to do the same mathematically, and that's what he was talking about there.
Yeah, no, I appreciate that. Are you familiar with a theodolite?
Yeah, only passing. I mean, my understanding is that you can very, very accurately find horizontal angles and vertical angles, but not much more than that.
But like, as far as like first principles of what the instrument it is, like you'd set it up properly, and you could, if you within that X, Y, Z coordinates, so you'd have your X and Y, that horizontal azimuth. Then you'd have your Z, the vertical. And so that instrument at that point, you set it up properly, you'd have that, right? The Cartesian.
My understanding, Buster, and if anybody else can correct me if I'm wrong, because I have not used a theodolite, but my understanding, Buster, is that there's no X, Y, and Z theodolite use. It is purely angle relationships. There's a horizontal angle and a vertical angle. And you might be able to translate that later on into Y's and Z's, but the theodolite does not have a distance measuring capability, so you wouldn't really be able to know, how far something is unless you took multiple measurements from multiple locations.
That's not us. I'm pausing it here. Yeah, if you don't get distressed by screaming kids in the background, that's flat earth math. I think that's happening at his house. He doesn't seem bothered about it. So what he's saying here is that a theodolite, it's his knowledge, measures angles in the horizontal and the vertical. But then he says he also claims to be an expert geometer. And then he says that there is no X, Y, and Z relationship on the theodolite. But I would just say that knowing that the tool measures on the horizontal plane, the X and the Y axis, and then vertical angles in the Z. Of course, the tool has to be set up in the horizontal and the vertical, the X, Y, and Z. Otherwise, you can't measure angles in the X, Y, and Z. So, who's at fault here? Like, he does claim to be, I think Buster says it in a bit. He says about his critical thinking. Surely you should be able to work that out, shouldn't you? Without being told geometrically. If you claim to be an expert geometer, then you should know about the X, Y, and Z planes and the relationship that has to a theodolite that measures angles on the horizontal and vertical.
Yeah.
But, hey, who knows? This is Charles. We're dealing with sophistry, but this is a very strange type of sophistry. Very
Yeah, but
strange.
you could physically measure it as you're using the instrument.
Yeah, well, the thing is with land surveying, the whole principles of land surveying are based upon that if you have a triangle and you know one of the lengths of the triangle and two angles, then you could find the other two sides and the remaining third angle. But if you have a theodolite at one location, the only thing you can measure with that one location is just vertical angles and horizontal angles. That's my understanding.
Yeah, but you can measure distances as well, right?
Without moving the instrument, that's correct. You wouldn't be able to measure distance. But
No,
obviously,
no. You're not limited to just the theodolite when you're doing surveying in reality.
Right. You're the world is your oyster. You're doing surveying. You're allowed to walk around the field. You can't you're not stuck in the corner. It's just a theodolite, and you can't get out of theodolite prison. But yeah. So if you move the instrument, you make multiple readings. Sure.
But if you've got the instruments, it's set up properly. You wouldn't say that that's XYZ.
No, that's just my understanding. No.
But wait, so like if it's set up properly, the instrument can spin, and that's where you get the horizontal angles.
Right, angles, but not distances.
Yeah, but that's the XY.
You could say it's the X.
You notice that he's talking about distances now. I mean, that's his brain that's doing that. You can't seem to think that the horizontal of the angle is a horizontal. That's how you measure the angle horizontally, because you've set the tool up on the horizontal. You can turn the tool because it is set up horizontally. That's a horizontal angle. Angle on the horizontal, azimuthal angle, let's say. Why distance? Where does distance come into an angle? A theodolite is an angle measuring device. You can measure distances with other means. I mean, you are definitely allowed to do that. You're not limited to a theodolite.
XY plane, but you're only placing angles in the XY plane. So that's,
Yeah, but it's the XY plane.
The azimuthal plane.
No.
So you would
say,
say,
yeah. So like that's the
he's
XY
related
plane
the
that
XY plane
instrument is in.
to the azimuthal plane. He has.
Yeah, like I said, I am not a surveyor. I've never touched a theodolite, but my understanding is that when surveyors are out in the field, they're not talking about X, Y's, and Z's unless they have a GPS receiver is getting that data on the ECEF coordinate
But what
system.
if you can't get a GPS reading?
Oh yeah, well, land surveyors, existed hundreds of years before there was GPS. So, but any kind of land surveying, my understanding was all done with triangles, where you needed to have some kind of a baseline. Some kind of a length that was precisely known, and then you would place a theodolite at each end of that length and then measure angle measurements, and then you can draw all sorts of conclusions, including distances.
Yeah, but like that's the point. Like you get an angle, so on the horizontal azimuth, you can get an angle, right? Yeah. So if I wanted to get a 90-degree on that horizontal, I could acquire that with a theodolite.
Yeah, absolutely. But all I'm saying, Buster, and all I'm saying is that I just don't think that surveyors don't talk in terms of X, Y's, and Z's unless they're using the ECF coordinates. That usually requires GPS.
What's ECF coordinates?
Earth-centered, Earth-fixed, or something. I'm not 100% sure, but those were the coordinates that, like, the GPS that Jesse drove over the bridge. Like, that was the original question that you had for me. Was, it was X, Y, and Z, a point at the beginning of the bridge, X, Y, and Z over the middle of the bridge, and then X, Y, and Z over the end of the bridge. And then those 3 points were not collinear. So,
it's called ECEF. ECEF.
Okay, and then does it stand for Earth-centered, Earth-fixed?
Yeah.
Okay. Like I said, I'm not a surveyor, so.
I'm not either.
Remember the Earth-centered. Remember that. That'll be coming in quite important.
But we can talk about these things, right?
Yeah. I'm just trying to make sure that I'm not misrepresenting myself. Like I've seen on TV.
It's about trying to understand, like, gain an understanding about something. That's like you want to acquire knowledge on something.
Yes, absolutely.
Yeah. And we're just like, I'm totally talking about the rudimentary functions of what these instruments do. We're not getting super like that. The whole bridge thing, that's something that's like, I mean, I don't know. Like, if you figure that out, that like, good on you. But like for me, in my experience, watching people use those theodolites, they do, you know, they use like a grid system. So like the X, Y, Z. So the people I've seen use them, they actually hang a plumb bob as part of the setup.
Yeah, I mean,
I don't
you're
know.
not equating, or you're not trying to equate Jesse driving over the car with a thing on the roof of his car to a theodolite, are you?
No, I'm absolutely not. I was the only reason why I mentioned that, Bev, was that it was a computerized receiver, you know, transmitting and receiving from satellites, setting X, Y, and Z on the ECEF coordinate system.
Yeah, it's just plotting points.
Yeah, well, then that's where the 3 coplanar points come from. I know you like to say 3 coplanar points.
No.
Jesse
Oh,
said
Bev.
that.
Yeah, I was gonna say Bev only said it because Jesse said it.
Sure. But I mean, I think the reason why I think it's a joke is that the plane
It's not a
that
joke.
he's
Jesse
talking
said
about.
it.
Jesse said it.
I know, I get that.
Do you
I get
say-
that, but it's
do you
turned
think
into,
he said
it's
it
turned
for a
into a
joke?
meme. No, it's turned into a meme, kind of like Tis Globe. The thing that I think that you guys are getting humor in is that the 3 coplanar points, the plane is the vertical plane, not any kind of a horizontal plane.
Okay, right. So this we've been over this many times before, right? At Lake Pontchartrain Bridge, Jesse Kozlowski puts a thing on the roof of his car, a GPS unit, and drives across the bridge. Now, as we know, GPS just plots points. That's it. Those points are individual points for distance marking. So you can do straight lines between these points. That's what all they're meant for. So it doesn't do vertical. It doesn't plot a height on the vertical scale on the Z. It literally just goes and plots a point. Now you put that point on a map, and then you can measure straight line distances between these points. That's all Jesse did. Now, Jesse Kozlowski said within the video that he did with Soundly when he was going over it, that he plotted 3 points on the same level, one at each end of the bridge and one in the middle. And he called them 3 coplanar points. And as we know, 3 coplanar points are what form a triangle. And the triangle that's formed forms a plane. And then all of these 3 points that form the triangle are on the same plane. So the 3 points define the plane. So that's what Jesse Kozlowski said he did. Now, as Flat Earth Math, Charles has just stated, he says that's a vertical plane. The vertical plane that has been produced by Jesse Kozlowski with the 3 coplanar points, which Flat Earth Math Charles thinks is a joke. He was laughing at it. He literally thinks when Jesse Kozlowski said 3 coplanar points, he was joking. And then when we repeated it, 3 coplanar points, to show people exactly how a triangle's formed with 3 coplanar points, that's what it's called. It's basic, simple mathematical understanding of these 3 points make a triangle. But now, Charles has said, this is a vertical plane. Now that's pretty big news for acclaimed geometer. We'll go about this now.
So he's got 3 coplanar points.
You think
Wait,
that's
you
a
gotta-
vertical plane?
That's
No,
a
it's a vertical
contradiction.
plane.
You can't have a vertical
not a-
plane, can you?
Yes, you can.
You can have a vertical plane. But you're saying it's not a horizontal plane?
That's correct.
But you
There's
can
no
have
horizontal
a
plane.
horizontal plane, right?
Yes, but that does not include the 3 points, the start, middle, and end. that he was talking about when he said 3 coplanar points.
Okay.
He was talking about a vertical plane,
Okay,
and that's
right,
why I
okay.
think it's funny that you guys make a joke about it.
Brilliant. So perpendicular to that vertical plane would have a plane that goes from point A to point B at each end of the bridge. Right?
You
And
could
now,
construct-
now you're saying that that horizontal plane that is perpendicular to the vertical plane
I never called it
doesn't.
a horizontal plane.
No, I'm calling it horizontal plane, right? Perpendicular to the vertical plane that you've just called, right? I'm calling that horizontal because it is perpendicular, and it would have the point at each end of the bridge, right? You'll give me that mathematically.
I'm following along with what you're saying, but I am not going to call it a horizontal plane. That would not.
Okay, so here we go. He said that Jesse Kozlowski, 3 coplanar points, makes a vertical plane. I say, well, let's have a plane perpendicular to that. That's a horizontal plane, isn't it?
Well, yeah.
Well, I think this is
Has to
where
be.
we have to say sorry to people. Because, I mean, in normal life, that's fine, right? Mathematically brilliant. But within this particular arena, you're going to see some messed up minds. Let's say effed up minds. Just like Charles here, because this Betty's brought a perpendicular. I've just stated vertical plane, perpendicular to that, horizontal plane. I mean, of course you can have perpendicular, horizontal, vertical are perpendicular. Perpendicular planes are fine. If you can have a vertical plane, then you can have a horizontal plane perpendicular to it. Simple. But not so much so for the model afflicted, of which flat earth math is obviously model afflicted.
Not be a horizontal
Okay, right.
plane.
Well, here we go. You've got a vertical plane. You claimed that Jesse Kozlowski claimed 3 coplanar points on a vertical plane. Now,
Yes,
I'm saying
absolutely.
a horizontal plane perpendicular to that vertical plane that has points at each end of the bridge.
Yes, I understand what you're
Okay.
saying.
Now,
So,
you're saying
please continue.
the
I'm
middle
just-
point would not lie on the horizontal plane.
Right. I just disagree with the name of
And
the
there
plane,
would
but
be-
yes,
there
the middle
would be a
point would not be in that.
Yeah, a vertical distance
Yeah.
from that horizontal plane.
Yes.
For the
I just
midpoint.
disagree with the name. Yes. That would be the sagitta.
Okay, so
And it's
the,
like, I don't
the
know,
height
90
of
feet or
that
something.
vertical disk change is a vertical. It's on the vertical, right?
Yeah, well, it's a
So
distance in the
therefore,
vertical
it
plane.
would be a distance on the vertical plane, on the vertical datum change.
Well, you're throwing in the word datum and you're throwing in the word horizontal plane. I disagree with those
Why?
with those words.
Well, you
It's
just
just
you
using
claim,
pure-
You claim the vertical plane.
Right.
So
But I don't claim the
perpendicular to a
horizontal.
vertical plane would be horizontal.
No.
Why not? Vertical and
the
horizontal are perpendicular.
Okay. The rule
Betty's-
is you have a
Betty's logic.
plumb. No, the rule is you have a plumb, a vertical line. If you have a vertical line, anything you construct perpendicular to that will be horizontal.
So
So, here we go. Again, he's developed a vertical plane on there, which has been confirmed by Blue Marble Science. Thanks, Blue. He says, coplanar in a vertical plane, Bev. That's what Jesse said. It's not what Jesse said. He just said 3 coplanar points. And that's what he did. So, confirmed. Again, there's people speaking for Jesse Kozlowski. It's quite clear you can hear what Jesse says, and he doesn't mention anything about vertical. He just says 3 coplanar points. So, he said on the level, they're all the same level. And then he says 3 coplanar points. So, now we're dealing with a vertical plane. But we've just developed a horizontal plane and found that there's a change from the vertical plane of the center point that they're imagining on that vertical plane. Oh, wait a minute. I just need to get this one. Blue's, but I think Blue's confirming for us. I think it's even a welcome to the globe. The real globe. That's what we're after, Blue. That's all we're talking about. There you go. Check that out. Blue Marble says, perfect, Bev. You have a horizontal plane containing the endpoints. The center point is 90 feet above your horizontal plane. Welcome to the globe. So that would be horizontal and vertical being perpendicular. So the perpendicular relationship is fine, right? Horizontal, vertical, perpendicular, and then we can use Beddy's logic that he brought in earlier about perpendiculars and replace horizontal for A and vertical for B. And then we could end up with parallel horizontals. Horizontals being parallel. Thank you very much, Blue. You've been a great help. Okay, so obviously we're on this horizontal plane and there's a vertical change across the centre. I bet you're loving this, aren't you, Saragaki? This is perpendicular heaven.
Yep.
And Buster's got to be the only guy that's ever wrote perpendicularity into a song.
I would imagine so. Buster is a genius.
So, well, I mean, here we go. This is the model affliction confusion. Aporia,
horizontal lines, horizontal planes, but you can't do this long 26-mile distance and construct a horizontal plane. You just can't
made
do
a
that.
vertical plane.
But you can have a vertical plane, 25,000 miles, in area.
Well, so perpendicular to that
no,
would be
no,
horizontal.
No, the only thing you can make a perpendicular to is a plumb and call that horizontal.
So
that's where I was saying there's no exception.
See, the problem with that is that perpendicular to a line, it is a plane.
Yes, flat Earth math yet cannot understand, I think, that in his model, he cannot create vertical plane.
He doesn't understand that yet. No, you're right. He's a self-proclaimed expert geometer, but this expertise is slightly sophistical, let's say. It's a sophistical expertise in which he's got a few books and he can put them behind him on the shelf and he can imagine that he's got it, but geometry is entirely logic based. It's not as mathematical as he thinks it is with equations and calculus and stuff. It's entirely logical, of the mind, the reasoning process, sort of a code book hidden away within lines and triangles and circles. There is a logical method that'll help you sort your mind out. It'll help you see contradictions, help you spot them. It's a wonderful book, but it takes a while for you to get into it because this is a change of thought process, really. Obviously struggling for people like Charles. Let's continue.
I just one clarifier.
Sure.
You'd say plumb is vertical.
Yes.
Okay.
And those three coplanar points, you could line up three plumb bobs, and they would all be within that vertical plane, right? On that vertical.
But they would be diverging from each other.
What do you mean? No, they would all be on the vertical plane.
They would all be on the vertical plane, but they would be diverging from each other by about a third of a degree.
Diverging on the vertical plane. Whilst being on the same vertical plane, you're saying they would be diverging from the vertical?
Yeah. The plumb bobs, the string of the plumb bobs would all be coplanar. So you have 3 plumb bobs, 3 strings, all of them coplanar. Okay. But the actual orientation of the plumb bob, looking from the side angle, the Muppet vision, would be diverging by about 1/3 of a.
The plumb bob from the side angle. Go on. Just imagine that for a second. Plumb bob, side angle. Okay. Now we're there. You're on a vertical plane. Look at it from the side angle. The vertical. Yeah.
So I can look at plumb bob from any angle, and I think it would be still plumb bob. It means vertical. But that's me.
Yeah. Like any side angle looking at a plumb bob, it would still be a plumb bob, right? It doesn't.
How about if you're upside down?
Yeah, but the plumb bob would still be a plumb bob, wouldn't it? You wouldn't be able to look at it from an angle and get the plumb bob to tilt. I don't think. I mean, I don't know.
This is beyond nonsense. Yeah.
Well, this is where we've sort of brought this conversation into a place that isn't ready for it. I think I said that to Betty a couple of times, but Betty's brought this perpendicular in now, and it's forced flat Earth math, Charles, to face one of the demons, right? This perpendicularity. It's a straight line, Euclidean principles through and through, Pythagorean theorem. It's got everything in this, all wrapped up in one little argument about a straight line. Mass confusion when relating it to reality.
Degree.
It's terrible. It must be bad.
I never see that.
We were just talking about this.
Of course, it's impossible to see.
Exactly.
Why are you claiming it then? You claim it's just claimed impossible to see. Verticals. Yeah. Like, I don't know what he claimed. It's not impossible to see a plumb bob, and it's not impossible to see 2 plumb bobs lined up. So, not too sure what he's talking about.
It's impossible to see what he imagines, is what he means to say.
Yeah.
Yes, so it is impossible to see them being divergent.
Yes.
This is what is impossible.
I wish Buster was here, because I'm going to call this, it needs a nice name, Buster's something, because we've been dealing with level and horizontal purposely. I have. Because we want to try and focus the argument on the straight line. That's where it is mentally. Like the position of you understanding what a straight line is and how you understand it. Well, because we've been dealing with this, and the minds of everybody has been fixed on the horizontal, and obviously what this arena's done to that conversation, right? Obviously breeds this fantasy about circles and stuff, but this is the consequence of the vertical, of leaving it alone. Buster has developed a work-based conversation, because something he knows from his experience. He has a particular experience about something that most of us can reason, but Buster has an extra part of it. So I'll find a name for it. You're claiming an impossibility.
Oh, no.
Charles.
I'm saying that the only thing that I claim would be impossible is measuring 1/3 of a degree deviation from a string of a plumb bob to another string of a plumb bob, 26 miles away or whatever.
Sure. There's some claims of thousandths of a 3,600th of a degree. You're saying that's not... Are they making that shit up?
No, I'm saying the measurements of, for example, surveying measurements that can determine Earth's curvature do not involve measuring deviations of plumb bobs. You could
What?
do
Wait, say that
reciprocal
again.
zenith angle.
Wait. Do you know, have you heard of a guy that may possibly live in Maine?
Yes, and he may possibly be a surveyor. Yes.
Okay. And have you heard of the distance that he supposedly did it? I think it was around about 500 meters.
Yeah. I've talked to Jesse about that as well. Jesse's done it. I think in as short as 500 meters, he's measured Earth curvature.
What do you mean Earth curvature?
Well, because the Earth is a globe.
We're talking about verticals, right? We're talking about plumb bobs, and you've just said it was impossible to do it.
I'm saying,
but you've got
okay,
people that probably don't live in Maine claiming to do it, and now you're talking about Jesse Kozlowski.
Okay, so
doing
let's
similar sort of things, but you've just claimed impossible.
Let's back up a second. As long as we're crystal clear on what I said was impossible.
Back up to the bit where you said it was impossible, right? Let's start
there. Let's clarify what I said was impossible. If you hang two plumb bobs 26 miles apart, what I claimed was impossible was literally measuring the deviation of the strings of those plumb bobs, not using any other instruments. Not using theodolites, not using anything, literally just somehow determining that the string of one plumb bob is between a third and a half of a degree.
But forget about that then. Let's go to this. Right, so I just put in here, this has been claimed to have been done by, like he says, Jesse Kozlowski and that other guy that probably doesn't live in Maine. You can never trust somebody who you know's a liar. And those are the two guys that have claimed that plumb lines deviate. In fact, there's another one as well. A guy called Blue Marble Science. He's got a YouTube channel. He claims to have done this also. So you've got Jesse Kozlowski, who ran away because he couldn't justify his claim of saying that level separates from horizontal. You've got this guy who probably doesn't live in Maine that has shown you that he can't even set his tools up, yet he has claimed to have measured plumb lines diverging over a distance of 500 meters, which we showed, and we have shown, that the claimed measurements that he made are impossible. Just like Charles says, impossible to do this. Yet people have claimed to be able to do it. And we've been looking at this for quite a while now, watching a strange group of people who seem to just contradict themselves and their friends. But that's okay, because their entire model is built around contradictions. And this is where we're at. This is where we call it aporia, a state of aporia. But this is a model-induced state of aporia that only happens to a certain group of people. The ones that have accepted contradictions. Yeah, Blue says that he's done reciprocal zenith angle measurements. He says that proves this as also. So there's three people that I know that have claimed, or there's a few people that have claimed to have, other people have claimed to have done it. So we say that, at least. Anybody that has been claimed to have done it has run away. They've gone. They can't speak of it. So, I don't know how much of a claim that is, seeing as other people say it's impossible. Maybe that's why these people that have claimed to have done it have disappeared. They've just run away. They've done a Jesse Kozlowski. Because people will ask them how they have managed to do the impossible. And they'll say, I don't know. It's impossible. We can't have done it. That's why they've gone. All sorts of people don't claim to have done the impossible, though, Blue. Just you, Jesse Kozlowski, and supposedly the guy who doesn't live in Maine. What a character. They've all disappeared. Only Blue Marble Science left. Wonder why that is. But Blue Marble Science has already stated that Blue Marble Science is a fictional science. It doesn't exist as a science. So I mean, it could be a contradictory science. It's a new type of science. This 500 meter one that Jesse Kozlowski and the guy that probably doesn't live in Maine.
Yeah, I forget when I was talking to Jesse about it. I said, "What's the shortest?" He says, "He's done it in a parking lot." And what he said was, what he meant was measuring Earth curvature. I don't know exactly how, using what surveying technique. So I'm not the expert here, and I can't speak for.
But you just blindly believe it?
Yeah. Well,
No, I don't blindly believe
it was impossible, right? But Jesse Kozlowski said it. So I mean,
I've measured the shape of the Earth myself in multiple different ways. So I can confirm 100% that the Earth is a globe. I've never used surveying instruments to do it. I use other means. But so it's not a blind belief. I absolutely 100% with 100% of my data gathering know the Earth is a globe.
Yeah, we can do that. We can all do that, right?
Yes, that's what my channel is all about.
Yeah,
no,
yeah.
not tis globe.
Yeah,
Go
tis
outside and make
globe.
careful observation. No, that's a silly meme.
What do you mean? It's not a silly meme. It's a.
It's a silly meme. It's what people post anytime I say the Earth is a globe. People are like, tis globe. And there's that funny black and white guy.
Confirmation.
No, to answer Buster's question it is not a blind belief I have. It is one that is from numerous field observations, predictions that I've made. I've literally
we are talking about the plumb bobs here, right?
Sure, and that's what I said was impossible, is measuring the deviation of the plumb bobs.
How good would you say your critical thinking skills are?
Excellent.
Sorry?
Excellent. I'm one of the few globers that actually has been casting a cocked eye towards all this stuff in the last 3 years. The worldwide medical event, which we will not name.
No,
I'm like the only glober
No. We're talking
that I
about
know.
Jesse Kozlowski.
So it's like I'm critical
That's
thinking.
not
Yes,
thinking, is it?
I'm not, I'm
Just
just saying
reasonings-
that I don't just accept what the authorities tell me.
No.
That's
I wasn't
the point
going down
for me.
I wasn't going down that road. Like, how good would you say you have a reasonably good critical thinking skill?
Excellent.
Okay, excellent. So earlier I was talking about the functions of these instruments and just the geometry involved.
Yes.
Like, you think you could use your excellent critical thinking skills to work out how they work?
Yes. Yeah. I mean, to it, you're asking me to spitball something where there's literally people who have trained in it, and I have not trained in it. So it's like,
All right. Yeah.
there's a big asterisk because I am not a surveyor. I've never touched a theodolite, so not my area of expertise.
It was
You
just
talk about geometry, just not necessarily exactly what you could do with the instrument. My understanding is you can measure horizontal and vertical angles.
within the XYZ.
Again, I don't think they use those terms.
It's a grid. It would be a grid reference system.
I'm sure they use a grid reference system. I'm pretty sure they do not use X, Y, and Z unless they're using GPS, CEF.
What if they can't use? Like, I work in a field where they can't use GPS, but they use the instruments and the plumb bob.
Yeah, well, you should talk to them about whether they use the terms X, Y, and Z.
Well,
you said you work with guys.
Yes, and I've talked to them and I've watched them do amazing things with just a theodolite and a plumb bob.
Okay, what do they say about X, Y, and Z?
They have the instrument set up to where it spins on the X and Y, and then the Z is the plumb bob that's set up underneath it. That, and then they cite to another. Yeah.
No, Buster, that wasn't my question. My question is that you said you've talked to these guys. So have you posed that question to them? Do they use the letters X, Y, and Z when they're making their measurements with the theodolite?
What would you say about a plan view map? Would you say that's an XY map?
You could establish any axes you want. There's some disagreement about whether it's the XY plane or whether it's the some other plane.
Plan view?
Depends on what. Yeah, a plan view versus an elevation view. Absolutely. You could arbitrarily label No, you can arbitrarily label the
you
axes
think
with
there's a
whatever level,
difference,
level
Charles?
No, what's the
labels you
difference
want.
between an elevation view and a plan view?
Well, usually the plan view is overhead, bird's eye view, and a
That'd be
elevation
the
view.
X and Y.
But the thing is, and you could look it up
And
on,
the
on
elevation-
the web. There's
elevation,
different
Charles.
strokes.
Would be from the X and Y to
Well,
the.
but all I'm saying is
on the
there's nothing
on
about
the
there's
vertical plane, isn't it, Charles? Isn't the elevation on the vertical plane, like you said, Jesse Kozlowski and his 3 coplanar points? Would that not be the vertical plane, like elevation profiles?
So if we're talking about the elevation profile of a building, then vertical is synonymous with what do you say? Vertical is synonymous with elevation on
Yeah,
a,
so
say
are
a
you-
building.
Is
A
that
building
not what
plane.
you were saying with Jesse Kozlowski then? The vertical plane?
No, because it wasn't a building site. It was the size of a 26-mile long bridge.
Yeah, but it's still the vertical
That was a
plane.
building. That's
right?
the building
But
site.
to get back to Buster's
Yeah,
question
but
about
Charles,
the X, Y, and the Z.
Charles, wait a minute. The bridge was built. And Jesse
Yes, the
Kozlowski
bridge.
drove over that bridge, and you
Yes.
said it was a vertical plane. Now, are elevation profiles on the vertical plane?
I just want to clarify
And
that
like that bit that you had in the
elevation
middle
is
that
the
wasn't
same
on that
as
horizontal
vertical,
plane, that has
like
a
a
vertical
size of a building.
elevation change, doesn't it?
okay, so but the thing is, Bob's
Can you see everybody see the situation he's in now? He's got a vertical plane across the bridge, all the way across a vertical plane, and an elevation profile is a view on the vertical plane with that horizontal that he placed from A to B. And he said, and Blue Marble stated as well, that the bit in the middle is 90 foot above. That doesn't seem to work, does it? With an elevation profile on a vertical plane cutting through the bridge as Jesse Kozlowski drove over it. That vertical plane, Blue Marble said, is 90 foot up in the centre. That's right, isn't it, Blue? 90 foot difference. And do we see? What did he say? Perfect, Bev. You have a horizontal plane containing the endpoints. The centre point is 90 foot above your horizontal plane. Welcome to the globe. So the elevation profile on the vertical plane for Lake Pontchartrain Bridge has a 90 foot rise in the centre of it. Welcome to the globe, says Blue Marble Science. 'Tis globe. I mean, everybody, right? I think we can all agree that solved that. We've sorted it. There's a 90 foot hump in the middle of the elevation profile of Lake Pontchartrain Bridge on the vertical.
diverge with great
It's been
distance,
measured.
so I
Yeah,
just have
it's
to be very
been done.
careful with my language, going beyond the size of a building site.
The building
guys like
site
to try
of
to-
the
you try-
Lake Pontchartrain Bridge. Yeah, he doesn't want to go on a building site yet. Lake Pontchartrain Bridge has been built. So that would be the building site for Lake Pontchartrain Bridge, would be the entirety of Lake Pontchartrain Bridge, right? That's the building site that we're talking about. We're talking about a building, a bridge, across a lake and a vertical plane, claimed by Jesse Kozlowski and a guy called Flat Earth Math and Blue Marble Science. They're all teaming up.
Yeah, but he's not able to say that. Because it would
Blue
destroy
Marble
his-
said it. Like when they team
Yes,
up
I know.
together, right? Other people in the chat to other people saying it, they can sort of back each other up by the things that they're saying. So, like, we now know, although Blue Marble's not said it for him, Charles is in the position where he's trying to deal with it. Yeah, he's struggling now because he's now been placed with the elevation profile. I quite enjoy these conversations, to be honest.
Yes,
And the
yes,
the
that's a
vertical
bit.
plane
That's a
that
bit
Jesse
bigger. That's a
Kozlowski
bit bigger.
measured, according to you.
Oh, I'm saying that the three coplanar points, the plane that he's talking about is the vertical plane.
From an
Right?
elevation
That
view.
plane ultimately intersects the center of
like
the Earth.
elevation profiles. So what we can do is we can plot these points on this thing like an elevation profile.
Just going to say, I'm just going to urge caution, because if you have an elevation profile of something larger than a building, then vertical and
what do you
elevation,
know,
yeah, you
Charles?
can't.
What do you know about building sites, elevation profiles, or plan views? Right, what do you know about that?
I know enough to discuss it. Just as
you're
Buster was
urging
talking about.
caution, right? Do you know what you're urging
you guys
caution
are
for?
Yes.
You're the one that's claimed a vertical plane.
Because the questions, Bev, the questions that you're asking only make sense if the Earth is not a globe. That's why I'm urging caution. Okay? And I know we've gone through this many times.
Charles, everybody knows tis globe. Don't worry about it.
That's a meme. Tis globe is a meme.
Yeah, but
okay, I'm talking about the actual spherical shape of the planet.
Everything that we do in reality will prove the real globe, right?
That there are hills and valleys. That the Earth is not.
No. This what we're doing right now will prove the real globe, because this is Jesse Kozlowski, right? What do you think he's been doing?
When you say the word globe, you mean the meme. You don't mean the shape of the Earth. Okay?
No, I just mean to prove, right? It's
actually
within reality will prove reality to be the real globe, right? Okay, everybody knows that where we live is the real globe, the real globe. So Jesse Kozlowski's measured a vertical plane, according to you. I mean, you're the one that put those three coplanar points on a vertical plane.
Well, and if you listen to him, that's what he talked about.
Did he?
So, Bev, when you say the real globe, indicating something that is not a globe, you are practicing sophistry.
What do you mean? What's not a globe? Did you hear that? He's whenever you say tis globe, you're practicing sophistry.
Oh yeah,
it's great, isn't it? Like, I mean, how? Really?
For me, this is psychologically very interesting, because when you say tis globe, he's just like offended, but when you say real globe, he denies it also. So it's just very interesting.
I'm thinking of a tis globe range of t-shirts. Like, you could have tis globe, ask me about it, right? And see who'd be willing to talk to you about tis globe and the proofs that they have, how they know it, the real globe.
And you are saying the phrase, the real globe.
Yes.
And what you have in your mind is not a oblate spheroid.
What do you mean? What do you mean that what I've got in my mind? Can you hear the words, Charles?
Yeah, I hear the words, and you're practicing sophistry, because you do not mean the oblate spheroid.
The real globe.
I know the Earth is shaped.
I mean, the real globe. Whatever the real globe is, will be proved by facts of reality.
You keep using the word globe.
Yeah.
Keep using the word globe. That's sophistry.
What, you think it's sophistry to use the globe?
No.
The real globe.
Thing is, I know the Earth is a globe, and you dispute that.
Everybody knows it's globe.
No,
everybody knows it.
No, I'm not talking about a meme. I'm talking about the actual oblate spheroid shape of the planet.
Yes, everybody knows that. Now,
no, everybody does not know that.
What do you mean everybody doesn't know it?
Oh, if you were to poll the people who are just in voice chat, do you think the Earth is an oblate spheroid?
The real globe, everybody knows here.
Right? No, don't change the language. Change the language. Don't say.
Look, we're talking about the real globe. Everybody knows. We all live in reality, and reality is tis globe. Everybody knows it. It's pointless to argue about it. Like, everybody knows it to be true. So let's just talk about it. Let's all get together, one happy thing, and say, the real globe, it's there. Everyone can see it. let's talk about what our perceptions of globe are, and then we'll just go from there. What can we prove in reality? And that's got to be the real globe, because everybody knows, right? There's no such in geometry, and there's no such thing as flat. It doesn't have a reference in geometry. And do you know what shape a globe is in geometry? So it's not. A globe isn't a shape in geometry.
Ball is a shape, or sphere.
Yeah. A globe is a whatever you imagine it is. It lives in the metaphysics. Just imagine whatever you want. But you can only prove it to be what it is. Let's talk about that. That's what I'm saying to Charles. Everybody knows what they know already. Let's just talk about it. It's crazy to do all of this sort of stuff. Crazy.
Tis globe.
globe?
Tis globe. Everyone knows tis globe.
Yeah,
Because
what's
that's
up with
a
globe?
meme.
The
So,
globe's a meme.
if we
Okay.
tis globe
I
is a meme.
suppose it is a meme. It must be
Tis
silly,
globe is a
right?
meme.
The real
And it is a
globe is a
sophist
meme, and people should stop using it.
Tis globe is a
Is
meme.
that because you
So-
want the flat Earth, right? Your flat Earth math.
My channel is dedicated to the math and science of the flat Earth debate, and it always has.
Flat Earth debate.
Yes.
The maths
I
and science
was
of
using-
flat Earth debate. That's Nathan
was
Oakley. Why
using-
don't you
I
go
was-
over there then?
Because I used
You've
that
dedicated a
language
channel
before
to the flat
he
Earth
made
debate.
his
Nathan
channel.
Oakley and all of those guys. I bet they're proud.
His channel called Flat Earth Debate was created after I made my channel. So I can't help that he took the name, but it's the words that I used in my description.
So you use flat
For-
Earth first.
I used Flat Earth Debate in my description
Yeah.
before Nathan Oakley created his Flat Earth Debate show.
Yeah, so
That's what I'm
Nathan
saying.
Oakley, inspired by flat Earth mathematics.
No, I don't think he even
in
read
order
the
to make
description.
a debate thing, right? Because he probably wanted you to be part of it.
Oh, he did not have anything. He's had very choice words. Me, most of them profanity. But anyway, I think the thing is, it's very interesting to hear you talk about the Greek scholars and thinkers and rhetoricians and
No, we were
philosophers.
talking about Jeren, actually. Jeren and Nathan
No,
Oakley.
but
and
what I'm
their,
saying is
the angle.
if you take a look at the description of sophistry, every time you say "tis globe" is an example of sophistry. So it would be nice if you would not say that, because it muddies the water.
Sophistry in what way? Go on, explain.
Muddies the water.
Because when I say globe, what I mean is the actual oblate spheroid shape of the planet Earth. And you
How
can
do
have
you
a
use Cartesian
desktop globe
coordinates
to
on
model
that?
it. Sorry?
How do you use Cartesian coordinates on that?
You usually don't. I mean, the ECEF
They
coordinates are can be mapped over the globe. That's why, the ECF. That's why Jesse Kozlowski said 3 coplanar points, because you have an X, Y, and a Z, but they're
That's Cartesian coordinates.
Yes, Cartesian coordinates. The center of the X, Y, and Z is at the center of the Earth. Okay, and then the x-axis
like the
points
0,
out
0, 0 point.
0, 0, 0. That's
It's
the
right
center
in the
of
middle.
Earth. Right. And then the North Pole and the South Pole
the
are
middle.
on one of the axes. I don't remember which.
Are you sure? That's not
the
how it
prime
works,
meridian. The prime meridian, where it intersects the equator.
Is Z,
that's another one of the axes.
It's your Z-axis, the vertical.
I can look it up.
Charles.
The axes of the ECEF.
Is your Z-axis the vertical in your X, Y, Z?
No, because vertical is not defined in global geometry.
In Cartesian coordinates?
No, vertical is not defined in Cartesian coordinates.
Okay. Well, when you do a graph and you use X and Y in your mathematics classes.
Oh, like as an
school.
algebra teacher, sure. You could say that the y-axis is called vertical on that sheet of paper. Absolutely.
Right, so when you go to the Cartesian
do it all the
coordinates
time.
and you have X and Y, you have that as the horizontal plane, and you have Z as the in 3 dimensions, right? They have Z as being the vertical.
You could do that, you know, like with computer graphics, people do that all the time. But you can't say ECEF and then call one of those axes vertical.
I'm not saying ECEF, Charles. I'm saying X, Y, and Z, the Cartesian coordinates. The X, Y is the plane, and the Z is the elevation.
Okay. So, as I said earlier,
vertical datum, as they call it.
Okay, but as I said earlier, you could name any axes to be anything you want, anything that is convenient for you.
In the Cartesian coordinates, we have X, Y, and Z. Don't we?
Yes, and those letters do not correspond to anything in the real world until you make it so.
The X, Y is the horizontal, and the Z is vertical.
No.
No? Yes.
No.
Yes. Not unless you've said it. Not unless you say, "Hey, here's the plan of this building," and we're going to say the XY is the level plane of the first or the ground floor.
Horizontal.
And the height of the building, 10-story building, that goes in the Z direction. You could say that for a building.
Yeah, you do that. I mean, that's what they do.
But you could also have planned some different set of coordinates, a different orientation.
What, of the horizontal?
You could pick that to be the XZ plane to be the.
He's just talking about changing the letters of the planes, right? Like, poor guy, he's lost, right? He can't agree, for some reason, that the XY is horizontal and the Z would be vertical. I mean, that's how the tools are set up. I mean, why has he got a problem with it? There's a massive problem, and it's just in being able to convey information to each other. For some reason, he can't agree on a very simple fact. For a self-proclaimed expert geometer, he's not doing very well. Not very well at all.
The horizontal for your building, if you wanted to.
Are you sure?
Of course.
Like
my understanding is computer
you
graphics.
Just label the axis wrongly.
You can label however you want. Like, for example, I think we've talked about the computer graphics example. On a computer monitor, the X and the Y are the plane of the monitor. So the Y-axis is actually
when
vertical
you're doing
on your
plans,
monitor.
right?
The Y-axis points towards your
elevation
ceiling.
is always vertical.
No, you're not listening to me.
And your plan is
In
always
terms of-
horizontal.
But you completely ignored everything I just said.
I was
Computer
just pointing out
graphics.
to you. Yeah,
In
we
computer
know that. We've
graphics-
got depth of field. Yes, we know that.
Right, and the depth of field is usually the Z-axis because
I
the
told you
Y-axis points to the ceiling.
Got
and the
told
X-axis
that
is
by
horizontal.
your top guy, right? So don't worry.
Hang
about
on.
So,
Hang
but what
on.
I'm saying is, it's
But,
arbitrary. You
Charles.
could label them however you want.
Hang on, Charles.
Sure.
I look at a map every day, and it's a plan view map.
Okay.
Now, that plan view map is from a horizontal baseline, but it's hanging vertical.
Right. So we could play games as to whether something's vertical or whether. Yes. I totally get you.
You're looking at it. It's hanging on a vertical wall, but it's a plan view map, and everybody knows looking at it that what it is.
Yes.
It's the X and Y.
Well, yeah. Most
Grid
maps
system.
that I've seen, at least in this country, they label one of the axes with numbers and they label the other axes with letters. So they talk about grid square, C3, and everyone knows, you go across the C column and then you come down 3 squares. So most maps I've seen are not labeled with X and Y or
Northings
Z.
and Eastings, right? In the US, do you have that? Because we have grid coordinates in the UK.
But I'm not a surveyor, so I cannot say anything intelligently about
Don't
this.
say about a surveyor. The maps. You've seen a map in America, have you?
Yeah.
Right.
Yes,
Right,
and I
so
am
those
not a
maps,
surveyor,
you've
so I
just-
cannot talk
no,
about
like
grid
you've just
coordinates.
said,
Okay,
square.
I'm just letting you know.
I
do
heard
not
you,
know about
Charles.
these things.
Charles, I just heard you say square about the maps in America.
Yes. Like
right?
for
Now,
example, I
so
used
the
to have a map of
question was-
Philadelphia.
So
It
the
was labeled
question
with letters
was,
and numbers.
yeah. So the question was, northings and eastings? Is that what they call those perpendicular grid squares?
I have
that
no
you
idea.
said they letter them.
No idea.
Okay, so are one of them north, pointing north?
It depends on if that's convenient. For example, in Philadelphia, a major street that runs sort of north-south is called Broad Street.
Not,
but that does not run
Charles,
exactly
listen to me.
north-south.
You're talking about the
So-
streets. I'm talking about
Okay,
the
yeah,
grid lines.
Yeah, no, all right, but if
Charles.
you actually listen to what I'm saying, Bev, I am answering your question. Could you just listen for a moment?
Okay.
If you look at any street map of Philadelphia, they will have Broad Street oriented, quote unquote, vertically on the map. They'll have Market Street oriented horizontally. But Broad Street does not go north-south. It is a few degrees off of north-south. It's like 10 degrees
One
off.
vertically and one horizontally.
No, on the map, hanging on the wall. That's why when I'm using horizontal and vertical, I'm saying the map is hanging on the wall. The height of the map is Broad Street goes up and down on the map as it hangs on the wall. Okay, and that's how the map is designed. You'll have grid squares on this map, and those grid squares do not correspond to north, south, east, west. That's the point I'm trying to make. Is it depends on the map maker.
Okay,
Depends
well, I was
on the orientation.
thinking that you have northings and eastings.
Don't know anything about northings.
No,
and
hang on. Our maps are hanging on a wall vertically, and it's a grid system, and they absolutely have northings and eastings.
Well, I don't know anything about northings and eastings. All I know is that
Those
the
grids, the
vertical
squares.
orientation,
It's a grid
vertical
system, and, like,
orientation of maps of Philadelphia, because Philadelphia was one of the first cities in the United States that was actually planned with a grid system. I just posted it into text chat.
Okay,
So that big orange line, the big orange line that goes underneath Broad Street, that's called the Broad Street, the Broad Street line.
It looks like the underground, London Underground.
Yeah, and these maps were inspired by the London Underground.
So is that north then?
No, it is off of north. In fact, might be. Let me see if I could find a better one that
Where's
actually
the
has
grids?
This one doesn't. All right,
Ours, like we name our tunnels like they're such and such south.
I'm trying to find one that has.
Like we have a plan view just like that, but like our conveyor systems are named after the direction.
Right.
What
I
do
mean,
you
the thing
think
is,
about, what do you think about north, south, east, and west, Charles? Do you consider them perpendicular?
Absolutely.
Okay. So it would make sense if you had squares for them to follow that north, south, east, and west, right?
Well, but you run into problems in that. I don't know if you've seen the maps of the Great Plains where it's like, hey, it's flat land. Why don't we just have a bunch of squares? Well, the squares, like lines of latitude, aren't the same length.
That's why they use northings and eastings, Charles.
You can't. Oh, okay, and I don't know what that is because I'm not a surveyor.
You don't know what northings and eastings are.
I do not know what northings and eastings
You know the
are.
grid. So I have to point out again. The question we're talking about is latitude and longitude perpendicular. Well, similar sort of question. Maybe we want to try that, and maybe I'll put a new question up in a moment about this. Can't do it. We'll stick to it. But I mean, remember, north, south, east, and west are they perpendicular? Good question to ask. See, we're dealing with perpendiculars. There are a few things that we can deal with when we're talking about the relationship of what a perpendicular is. But this northings and eastings in America, which I believe the grid lines are in America, they're perpendicular, I presume. I know the grid lines that we have in the UK, grid reference system, they are north, where you line the grid lines up north. I think that's what I say anyway. Grids you have that you talking about, the square.
But they can't be perfect squares. That's the point I'm trying to make. They can't be perfect squares
They are
because
squares, though. They're grid. It's a grid reference system.
Well, the problem is, I mean, if you're talking about like a shopping mall,
So this is, I have to point out, a self-proclaimed geometry expert talking about grids, saying that they can't be. I'm pretty sure I heard him say they can't be squares.
Sure, but if you're talking about a map that covers all of the UK, a map that covers an entire US state, then they're not squares. They cannot be squares because lines of latitude
Why not?
Are shorter as you go northwards.
Does anyone know why lines that aren't perpendicular can't be? Should we bring Betty's perpendicular logic? Is there anywhere in that logical statement that says that they can't be squares within the perpendicular relationship of one straight line or two straight lines to another one straight line? If they're perpendicular to it, they form right angles. They form squares with right angles, don't you?
They form, yeah.
Mm-hmm. Why would somebody have a problem with perpendicular? Indeed. The grid squares can't be squares. Did you just say that?
All I'm saying is, and I don't know how surveyors talk about grid squares, the word square.
Yeah.
If the left side of that grid and the right side of that grid, if they both are considered north, then that cannot be an actual square.
But yeah,
it has to be
in
more
the
of
UK,
a trapezoid.
they have a grid reference system, and one of those lines of the grid is north.
Yeah, and I don't know about the grid reference system.
And the other one goes like east-west, because they're perpendicular. That's
all I'm saying is that if you have a large map, that the size of a country, the size of a large
like the UK
US state,
or is that
the size of a map? The UK, yeah, absolutely, because the UK, I don't know, it's like 10 degrees of latitude from north to south, or at least 5 degrees of latitude north to south, probably 5.
Entirely. What we've got is we've got an elevation vertical datum from one point down south, and all of the elevations are reference to that, and we also have a square grid system across the entirety of the UK.
And all I'm saying is that if you have a grid system made of squares,
and we also
then
then
the left side and the right side of those squares cannot both point north. That's what I'm saying.
And they're labeled as north.
They can't both be labeled north.
All of them.
Not if they're actual squares. If you have them not be squares.
It's a grid reference system, yeah.
Well, you're just repeating yourself. The grid reference system that you're talking about in
squares.
The UK.
Yes.
They could label them with the word square and have the word square not mean a geometric square. Then you could have the left side of that grid and the right side of the grid both point north. But if you want to have a geometric square, they can't both point north.
Did you hear that? A self-proclaimed geometry expert talking about a geometric square. So there's a not geometric square. Possibility of. Anyway. Like a square is a square.
If we can divide triangles into triangles and spherical triangles, so maybe we can divide squares into squares and spherical squares.
Geometric squares, right?
Geometric or non-geometric squares.
Non-geometric squares, yeah. Right.
In a grid map of the UK. Can we try to find one? Can you post one in chat? I'm just going to type grid map of UK. See what I come up with.
Yeah, you'll find that there is a grid reference system that goes out through the entire UK, and you can get maps for different areas and they've different scales.
And again, I'm not a surveyor. I just literally did a Google search, and this is called grid reference map. I don't know if this means anything. I don't know if this is official or not.
You can get them all labeled,
but do you see how the dotted blue, the dashed blue lines, like where it says North Atlantic Ocean? See that blue line that goes, towards the top of the map from the North Atlantic Ocean? Do you see how that is deviated from the black lines? Again, I don't know if this is an official
That's
grid
what
of
I was telling
anything.
you. We've got a grid for the map.
Right, but do you see that the lines that are pointing north are deviated from the actual grid, the actual black and white grid, or the black lines of the grid don't line up with the blue dashed lines that point to the North Pole.
So you're saying that the black line isn't north, pointing north?
Yes, yes, absolutely. Those black lines on the map I just posted are not pointing north.
But that's what you do, right? When you get a compass and you do orienteering,
north.
you orientate the map north to the compass.
Yeah, absolutely. I trained on that. I trained with the old-fashioned military compass. I did land navigation across the not across the United States. I did land navigation in California. I did it in New Jersey. I did it in New York State.
Then?
No, what I'm saying is I'm very familiar with land navigation.
And I'm telling you again, I'll tell you again, you put north, the compass, along those black lines.
Oh,
are you saying that's wrong, Charles?
I'm saying like the black line that goes through Ireland, that goes top and bottom on the map, to bottom, that goes through Ireland, that is not pointing north.
But when they get their maps and they all put north on the map, they line that black line up on the map, the grid references with north.
Right. Well, what I'm saying is you would not use this map, the map I posted in chat. You would not use that for land navigation. You would have
because all of those individual
grid.
Squares have their own grid, and they will all fit to that grid.
Right.
And you always
Mm-hmm.
orientate the black lines north.
Well, I'm just saying, if you see the black line that goes through Ireland, it goes through the R of Ireland. That black line is not pointing north. Okay, and that's clear because there's a blue dashed line that is pointing north.
You can say whatever you want, Charles. I'm telling you, right? Wait a minute. In the UK, when you get a map and you're doing orienteering, you put the compass and you line those black lines up to north.
Okay, so those would be different black lines than the black lines on this map.
No, that's what those black lines are. They have their own grid references, and you can find all of the maps for the UK aligned to those grids. And any one of those maps that you would pick up, you can orientate any one of those lines to north on the map.
Okay. SE asks, north is not north in Ireland. No, SE, if you look at the map that I posted in chat, there is a very faint dashed blue line. That dashed blue line points to the North Pole. That's what I'm saying. So yes, they do have north in Ireland. They can tell where north is.
The geographic North Pole, right?
The actual North Pole of the
right.
Of the
so
Earth.
Not the compass north.
Well, compass north would be the magnetic
lines.
north, which would be you'd have some sort of magnetic declination. It would be off by a little
that's
bit.
What you do. You orientate your maps to the compass, and those are black lines. That's what you do.
No, those black lines are absolutely not even magnetic north.
So you're saying it's wrong then? Anybody doing an orienteering and doing that where they align those black lines to north? You're saying they're doing the wrong thing?
No, Bev, I said nothing of the sort. I said that the map that I posted in chat of all of the United Kingdom is not used for orienteering. You would have a much, much smaller scale map for orienteering.
But all of those black lines would be in the same orientation because the grid, yes, Charles, the grid that you see on the screen for that particular map is just broke down into smaller scale.
No.
Yes.
Well, I mean, yes, but the thing is, they would indicate where. I don't know. Look up a grid map of Ireland. That would be very interesting.
I've got a grid map, a few grid maps of the UK. Right, it's just over the other side.
but the one that is the closer you are to Greenwich, the closer you are to the Greenwich meridian, the black grid line will line up. Pretty closely.
That's why they all line up north then, right? That's why we have the grid system in the UK. We're with the originators of it, probably because all of the grid lines were actually north, right? So that's what I'm saying, Charles. I'm saying practically
Grid,
when we
the
talk
grid lines
about
are all
them,
not north.
well, they are.
No, they're not. I mean, can't you see what's happening in Ireland? What do you think that blue line is doing? The one that passes through
Charles,
Ireland, the blue dashed line.
Are you saying that the grid lines that point north aren't pointing north? Is that your claim, Charles?
My claim is that the blue dashed line is pointing north. All of the blue dashed lines are pointing north on the map that I posted in chat. That's what I'm saying. Where do you think the blue dashed line is pointing? The one that passes through Ireland.
The blue dashed lines are. I'm telling you, the black lines are the ones that you orientate your compass to, north.
But you're not using this map to do orienteering. That's what we just said. That
you're not using it to do orienteering either.
You'd use a much smaller scale map.
But all of the black lines on the much smaller scale map are still orientated the same as those black lines there, Charles. You claim to be a maths teacher. What don't you understand about the grid system in the maps?
I understand that the North Pole is where all lines of longitude converge. So,
right.
Bev,
Charles, let me say it again. Is that the compass north? Is that where compass north points to that?
No, compass north is magnetic north.
When we orientate our maps to the black lines, right, they're not orientated to where you say the blue lines are going to. Is that correct?
Yeah. They're not.
Can I orientate my map in orienteering to north by the black lines then, like I say we can do?
No. The closest you have to a 0-degree magnetic declination, I just posted something, is in the
right. It goes down to is an understanding, right? There are multiple norths that people think of. This is one of them that I'm talking about. I'm talking about grid north. All of the lines are orientated to the north. That's called grid north, and you align your compass to that. He's thinking of a different north, but he can't say that. I mean, it's pretty obvious that he's thinking of a different north. But he can't admit that he's thinking of a different north than what I'm talking about. And he's telling me that I can't have the grid north that everybody knows about. I'm pretty sure. Both in America and the UK. The grid lines point north and east and west. North, south, east and west. It's a question. Are north, south, east and west perpendicular?
Southeast of the UK has a 0-degree magnetic declination. All these lines are not, these lines do not point north. They're just saying how far off north is, magnetic north is from grid north.
Okay.
Probably confused.
If we were to work out in the America, right, where you have northings and eastings, which are pretty similar, I'd say, to the grid lines in the UK. Would you say they're not?
Well, the problem is that they're square. They can't be squares because lines of latitude get shorter as you go northward.
We're not talking about lines of latitude, Charles. We're talking about northings and
but lines of latitude are east-west, 100%.
Oh,
okay. So if you take a look at Kansas.
Oh, wait. So now we've got a problem, I think. Is east-west perpendicular to north-south? Charles seems to think that the latitude is east-west. Again, I think this is dogmatic. Like dogmatic as in the perception that people have within this idea of perpendicularity. It's fantastic.
Just posted it in chat. If you take a look at Kansas, the left side of Kansas and the right side of Kansas, they look like they're pointed inward. So basically, because the left side of Kansas and the right side of Kansas follow lines of longitude, right? And literally the state gets less wide as you go northward. Of course, there's that rough area in the corner. I'm not talking about the rough area in the corner, but just the part that looks vaguely rectangular, the lower half of Kansas. Right? That is, or those lines are all oriented towards, I wanted to say grid north. What's it called? Geographic north. Right? The North Pole. Left side of Kansas, the left border of Kansas is geographic. It's the Kansas and Colorado. The Kansas-Colorado border on the west side of Kansas. That points to geographic north, North Pole. The right side of Kansas, that's where it borders, what, Missouri? That also points geographic north. Does this make sense? And those two lines are not, that's not parallel, you know, it's because the lines of longitude intersect at the North Pole.
Oh, perpendiculars. Are they perpendicular?
And everywhere, like literally every town in Kansas, you're going to have north, south, east, and west perpendicular to each other. Absolutely. Mm-hmm. Lower left corner, the lower left corner, that blue county, you've got a line of latitude and a line of longitude. In the lower right corner, the green county, a line of latitude, a line of longitude. Those are perpendicular. But those two lines that point north, they are deviated. They're deflected from each other, not parallel. And I think that was the point that I forget who was making. Was it Betty was making the point that, you know, on a map you have two lines that are perpendicular to another line, then
Betty's perpendicular proof.
Yeah. But does that make sense, Bev?
So there you go. He stated it for himself. He does have two lines perpendicular to another line, but he doesn't have them being parallel. The self-proclaimed geometer, expert geometer. It is his expertise. All caused by Betty's perpendicular logic. What, that you're trying to shit all over Betty's perpendicular proof?
No, everything Betty said was correct, but he was asking a question that was aimed at somebody who does not know the Earth is a oblate spheroid.
Yeah, no, he was doing perpendicular.
Well, he was doing perpendicular.
Like, what we could do, we could put he put longitude and latitude, but like you've just said, the north, south, east, and west are perpendicular. So you right. So this is important to note here. I know Betty's not around, but he might catch up with this. He's caused this. This is Betty's problem. Betty's brought a proof of perpendicularity. As we've seen, there are many things in reality that are classed as perpendicular. Like these things in reality have reality terms. Vertical, horizontal, reality. Plumb, level, obviously reality. North, south, east and west, definitely reality. All of these things are claimed to be perpendicular. Oh, and another one, latitude and longitude, perpendicular to each other. Now, that perpendicular relationship is the relationship of two straight lines. Anyone can deal with this. Yeah, and like Iridium says, ask a surveyor about perpendicular. Just check whether you can have perpendicular to a curve. The relationship of two straight lines. Vertical and horizontal. That's another perpendicular. There's quite a few things in reality that are perpendicular. A right angle. Pythagorean theorem provides a right angle. Could just replace one of them with north-south and the other one with east-west. Couldn't you?
Yeah, but he was being more specific with lines of latitude and lines of longitude. So, you know, one line of latitude, and then, for example, the bottom of Kansas. the south border of Kansas, that's a line of latitude, and then he has 2 lines of longitude that are separated from by a distance. That's
Yeah,
the
it'd be
point he
like,
was trying to make. That's why he used
north-south,
latitude
right?
and longitude. Sorry,
North-south.
latitude points north-south. Absolutely. But the point he was making is that if you're looking at the Kansas map, I got the Kansas map on my screen. Looking at the Kansas map, the southwest corner is that blue county. Those are right angles. That line of longitude meets that line of latitude. That's a right angle. The southeast corner of Kansas, where there's that the green county,
right angle.
the lower right, that's a line of latitude meeting a line of longitude. That is also perpendicular.
Another perpendicular. 2 perpendiculars meeting a line. Same line. Yeah. So would you agree with Betty's perpendicular logic then?
Well, no. What? And I think what he's saying
Betty's
is
textbook
that if
logic.
if the map, if the Earth were shaped more like if all horizontals are parallel, is what I'm trying to say this very gently. If all horizontals are parallel, then theoretically, his point number 3, all lines of longitude would have to be parallel to each other if they're both perpendicular to the same line of latitude.
Yeah, like north and south, like we did. Let's spell this out. North-south is perpendicular to east-west. Right? 2 lines, e.g. north-south, perpendicular to the same line, i.e. east-west.
Yes.
Are parallel to each other.
No. Well, not in the real world.
Oh, well,
it would be.
You're having to go at Betty's logic then, right?
No, Betty was trying to poke his finger in your ribs, playfully.
That's perpendicular. Do you hear that? Flat Earth Math said that Betty, when he put that logic about perpendicular, he was trying to poke us in the ribs. Literally. So, well done, Betty. You've brought this perpendicular logic. And as now Charles is showing you, the geometry expert has 2 lines perpendicular to another line, the same line, and not being parallel. And his justification is that Betty was just trying to poke us in the ribs with his perpendicular logic. Flat Earth Math, Charles. He does perpendicular logic.
Well, no, only
like
if
mathematically, right?
Only if it's a plane. Like only if we're talking about a plane.
Mathematically, we're talking about perpendicular, aren't we?
Yeah, well,
your flat Earth mathematics, right? So
I'm not. I'm Charles.
Mathematically, if east-west is perpendicular to north-south, then does that not make them parallel, like Betty says?
No.
Does it not?
Because the line of latitude is actually a curve. That's the part that he was trying to get you to acknowledge.
No. Perpendicular.
I get that. Perpendicular. But the actual line itself is a curve.
So north-south.
When you construct another perpendicular.
Is north-south perpendicular to east-west?
Yes.
Okay, now
the line,
is
the
it
line
okay?
Of latitude.
Is it okay for you to have 2 lines north-south perpendicular to the same east-west?
Yes, absolutely.
And then
that's the whole point.
Would that make those 2 north-south lines parallel?
Only if the line of longitude, only if the line of latitude were a Euclidean straight line, which it is not. That's the point he's trying to make. That's why he's poking his finger in your ribs.
Are you saying the east-west, or are you changing it back to latitude?
East-west line, the line of latitude that goes east-west. If that were a Euclidean straight line, then yes, north-south on the left side of Kansas would be parallel to the north-south line on the east side of Kansas. However, the line of latitude, the line that goes east-west, is curved. So when you make
so he's just curved one of the lines that he says was perpendicular, which is impossible. Yes. And he's a self-proclaimed geometry expert. It's just curving straight lines. I don't believe him. But I mean, who knows? I mean, modern teachers, I don't know. This guy's he claims to be a teacher also. Would you be happy with him teaching your child about, well, anything really? You can't follow basic mathematical logic. For the globe. Because 'tis globe. Has to be. You can't
Perpendicular
have
to
You
it on
can't
the
have-
west side of Kansas.
So you're
Curved in
you're
which
saying your
curved in which
initial
direction?
Yeah, your initial statement of north-south being perpendicular to east-west was a lie, right? Because
Oh, north-south is perpendicular to east.
But you've just said that east-west is a curve.
I'm saying that the line that traces east-west is a curve. Yes, absolutely.
Well, how can it be perpendicular then? Because perpendicular is a relationship of two straight lines to one another.
That's only in your definition. The whole rest of mathematics disagrees with you. That's the thing that
Are
this
you
whole
sure, Charles?
aporia, imaginometry. Didn't you invented it?
Did you hear
Oh.
that? Right, the
Yes, so-
the entirety of mathematics disagrees with me about perpendicular being the relationship of two straight lines, one to one another.
It is Euclidean definition. So, and I would say that this is the only one geometry that we have till now, which is consistent and logical. So,
Well, I've never seen another definition of perpendicular. I mean,
me
it's
too.
at right angles, and right means straight. That's two straight lines. A particular relationship, right? I mean, nobody even questions the all right angles are equal axiom of geometry. So how can they be curved?
they cannot because intersection of only intersection of straight lines can give you right angles everywhere. So if one of these lines would be curved, you cannot have right angles, because on one side of curve you would have a smaller angle, and on the other side you will have greater angle. So they cannot be.
They cannot be equal.
They cannot be equal. Yes.
Which breaks one of the other axioms that all right angles are equal. It's the necessity of them being straight lines. It's the only way that that relationship can occur. I mean, it's not because they decided to write those down as the axioms. That's literally a law. It's the two straight lines and relationship between the angles, between the opposite angles. They're equal.
Yes, and they can be equal only if both lines are straight.
Yeah.
If one of them is not, you cannot have that. So you will not fulfill this condition.
And this is a self-proclaimed geometry expert. I mean, some claim he's a geometry teacher, but I mean, you'd have to worry about the kids under his charge if this is a true claim about him being a geometry teacher, and even a mathematics teacher. I struggle. Literally going against basic logic.
Imaginometry, right? You're the creator of it. In imaginometry, you can only have perpendiculars between straight lines. But in the real world of actual geometry,
That's
you
a
can have perpendiculars. You can have perpendiculars between curves and straight lines, between curves and curves, right?
But not
And
between.
that's
He's saying that in imaginometry you can only have perpendiculars
this is
between
projection.
straight lines.
This is
Yeah,
pure projection.
I call this a bit of a mental break that is occurring.
Yeah, yes, and projection is effect of that.
Mhm.
Because he has to. This is self-defense.
He's in
So-
aporia. He did mention aporia, but this is what happens. What I call this. This is cognitive dissonance. He's stuck in a place of aporia now, where he's having to affirm the antecedent and deny the consequent. This is what happens to your mind when you're stuck in that place of contradicting yourself. He's having to contradict himself, and that obviously causes problems. Vertical and horizontal, right?
Well, let's leave aside those labels out of it. We're focusing on north, south, and east.
You're saying you can have perpendiculars to straight lines, to curves, to circles, and all of that, but not to vertical and horizontal. Like, that's
so
fucking ridiculous, Charles.
Okay, if you're
a joke.
If you insist,
you are a joke that has been led by a model. Like, you're the most model obsessed person I've ever fucking known. You're a joke.
You just asked a question. You won't let me answer.
No, because you just fucking said something so stupid. Can't believe it.
Vertical is aligned with plumb.
You claim to be a mathematician.
Vertical is aligned with plumb. Do you agree with me?
Wait. Vertical is aligned with plumb. Like this, I asked this earlier. This was like 30, 40 minutes ago.
Yes. And vertical is always aligned with plumb.
Okay,
anything you construct perpendicular, vertical, to a vertical plumb bob, anything you construct perpendicular to that will be horizontal.
Okay, here we go. All right, perfect segue. I'm going to construct a theodolite perpendicular to plumb.
You mean the horizontal plane of a theodolite perpendicular to plumb? What you meant?
That it's in the instrumentation. It actually is called a horizontal plate. Like that's what you get.
Yes, I understand.
Yeah, so it's. I'm going to construct that horizontal plane at azimuth on that in that theodolite underneath a plumb that's vertical. Okay. All right, perfect. It has a crosshair in the sighting, right?
I've never looked through one, so I'm not. I know there's a crosshair in an auto level. I don't know what it looks like in a theodolite, because the theodolite you could elevate the telescope. You could point to the dipper if you wanted to. So I just don't know the technicalities of the crosshair business.
That's the whole purpose of. You said you had excellent critical thinking skills.
I do.
I'm highly questioning that right now.
No, but here, Buster, you have to understand. In an auto level, there is a little prism that is hanging on a little pendulum, so that you are pointing at sort of at the horizon, or if you're pointing at a distant object, you have a little crosshair, and if you adjust your auto level slightly up or slightly down, the crosshair will. It will still point to horizontal, even if you are moving your instrument a little bit.
There's a crosshair in a theodolite too. That's the whole point.
But here's the thing with the crosshair and the theodolite is the crosshair and the theodolite is, my understanding, is that it is not like the crosshair in a auto level, and that it doesn't show horizontal. It actually shows you're targeting for a vertical angle measurement. So you could point it up at the top of a building, right? So you can have a crosshair and you're pointing at the top of a building. You're angling your theodolite up at the top of a building or the top of a hill. Okay.
So
I am not a surveyor. I have never touched a theodolite.
You can't set it to 0, 0. Like you set the instrument up properly. You can spin it. You can you can hang it a plumb bob directly underneath it.
Yeah,
I get that.
In
the reticule of it, like that crosshair that's in a theodolite is not meant to represent how you've set it up properly.
Okay, so we never got to your question. I just wanted to clarify that just want to be careful with the language. So, but let's get to your question about this theodolite that is oriented. The horizontal plane of the theodolite is horizontal. It's perpendicular to vertical.
Is the crosshair in a theodolite meant to represent that perpendicular properties?
I don't think so. And again, I'm just
Why
going
not?
off the top of my head. I've never touched a theodolite.
Why?
So
you said you were excellent at critical thinking skills. Like, this is baffling.
So you tell me, Buster. A theodolite was an instrument designed to carefully measure horizontal and vertical angles, which means you could literally take a theodolite to downtown Philadelphia and you could angle it up and point it at the top of the nearest skyscraper.
I'm talking about
I'm
the
hoping that
rudimentary-
you would say that crosshair is not perpendicular to plumb.
The whole point of setting the instrument up properly is to get it to a zero, to get it to
Yeah, I
the
get you.
lined
But
up.
if you're elevating the telescope like at a 45-degree angle,
No. Not wait. Before you eat, we're talking about first principles here. We're talking about
Okay.
setting the instrument up. This is like we're talking about reasoning skills. The whole point of having a crosshair in the reticule is to set the instrument up properly so that the vertical and the horizontal crosshairs are aligned. That's the whole point of setting it up. Like that's the zero.
Right. And just I hope you're patient with me. I have literally never looked through a theodolite, and I have no, practical knowledge, or even I have never even read about how you zero a theodolite. So
Okay.
if you're asking me questions about the crosshair, I cannot answer those questions.
Well, you were
Okay.
more than willing to talk about the crosshairs in an auto level, but you're not willing
Yes,
to talk
because the
about one in
crosshair in an auto
oh,
level,
in
I
a-
know for a fact is aligned with a little prism that has a pendulum, which means it is aligned with plumb. So the crosshair in an auto level is a horizontal projection of your horizontal plane at your eye level.
Well, how would you ever know you're measuring angles with a theodolite if you don't know the first principles of how to set it up? How would you ever know what angle you're getting if you don't know you've set it up properly?
No. Okay, so I think we're talking past each other. Presumably, the person who is setting up the theodolite knows what he's doing. So let's say the theodolite is set up correctly. All I'm saying is don't ask me about the crosshair. I don't know what the crosshair in a theodolite does, other than you could elevate the telescope 45 degrees, in which case the crosshair is not, it's not horizontal, unlike an auto level, right? I don't know what the crosshairs do when the telescope is horizontal. I don't know. I've never touched a theodolite. I've never read a theodolite manual. Okay, so that's why I'm just saying. As long as you're not asking me a question about how you set up a theodolite, I don't know how you set up a theodolite. I know it's supposed to be set up properly, but I don't have technical knowledge, and I think that's kind of what you're getting at. It was this crosshair business. I don't know. Okay. I've got lots of critical thinking, but I literally don't know how the instrument works. Right? So other than it is used to measure horizontal and vertical angles if it's set up properly.
It's the same crosshair that references vertical and horizontal to get to get what you call vertical and horizontal angles. That's what those crosshairs are meant for.
Yeah, but I don't know anything more than that. Right, because so when you look at the crosshair, it is perpendicular to plumb. I don't know it's perpendicular. Why would it be perpendicular to plumb?
Because you set the instrument up properly.
But what if the telescope's at a 45-degree angle? You're no longer perpendicular to plumb. That doesn't make any sense. The theodolite's designed to measure vertical angles. You're pointing at the top of a skyscraper.
How do you know you're measuring a vertical angle if you don't know you've set the instrument up properly?
No, you set the instrument up properly, however that's done. I don't know how that's done. Once the instrument is set up properly, you can make all the measurements you like. I just don't know how to set the instrument up properly. I have a few ideas, but I've never touched a theodolite, and I am not a surveyor. I can't just conjure up the way of setting a theodolite up.
Yeah.
Yeah, well done. Yeah.
Yeah, I was going to mention that.
I don't get what the question was, because it seemed to be, Buster, that your question is a technical question about theodolites. I'm telling you, I've never touched one.
You say that it can measure angles vertically and horizontally.
If it's set up properly, and presumably if you own a theodolite, you know how to set it up properly.
Yeah, like you're turning it back on me. I said that in the beginning, but now you're saying that back to me.
No. I'm saying that
Yeah.
if one has a theodolite, if a person has a theodolite,
okay,
assuming that person knows how to set up the instrument properly, you can't just slap it on a tripod.
Right.
You have to do a procedure. I don't know what that procedure is. I've said it to you 10 times already.
So
I don't know what the procedure is for setting up a theodolite. But once it's set up, once the theodolite is set up, and you're golden. You can measure vertical and horizontal angles all day, and they'll probably be accurate. Okay? It just seems like what you're asking.
Probably, maybe.
Well,
like,
but
but you
within
don't know
a few arc seconds or
you,
whatever.
You just
It's
believe
the precision of the instrument. Arc seconds.
You just believe that Jesse Kozlowski did it. You don't know how. You don't know why. I mean, he probably did it. Probably.
Well, being that he is a professional surveyor with a license that is for public record, I think that's a pretty safe assumption.
You just believe him.
Well, I have no reason to disbelieve him. Like, he's never, ever, ever said anything to me that is proven to be not 100% the truth.
You're not willing to use your critical thinking skills to work through it yourself. You just believe Jesse Kozlowski did it. It's just a
Buster,
known thing.
Buster, you keep challenging me on my critical thinking skills on the setup of an instrument I have never touched. It's like asking me about diesel mechanics. Like,
No,
I
it's
not.
a
gasoline car.
Would you?
I don't know how the glow
That's
plugs
a false
work.
equivocation
Right?
fallacy.
No,
That's false equivocation. Like, all I'm asking you is, are you geometrically, like, how sound is your geometry?
very sound.
Very sound. That's the whole point of how these tools work, is sound geometry.
Yes,
And
but I've never
I asked
touched
you
it.
how you. No, wait. I asked you how your critical thinking skills were. Excellent. These tools use sound geometry. You would agree, I think, but you can't make the connection.
Well, no, what you're asking me to do is make a connection with an instrument I have never touched.
It's an instrument that has sound geometric principles attached to it.
Angle measuring. It's an angle measuring device.
Yeah, are angles geometric?
Yes, but
yes. Are they
all I'm saying is,
soundly
Buster,
geometric?
Buster, why don't we skip the part where we set the theodolite up accurately? Let's just say
That's the whole point of it.
Okay, well then you got to talk to some other guy. You got to talk to a surveyor, somebody with a theodolite.
Obviously.
I mean, didn't you say you have guys at your work site that use theodolites?
Yes.
Then have this conversation with that person.
We've already had it,
this
Charles.
Yes.
Like, what you seem to be not recognizing is that we have experience in this, whereas you quite clearly do not.
Well, I've never made a claim about the shape of the Earth that was based on my using a theodolite.
Nobody is making a claim about the shape of the Earth here, Charles.
Yeah, but you guys disagree with me about the shape of the Earth. That's the whole
Charles,
point of
we
my
all
engagement with
agree.
you.
Everyone knows 'tis globe.
It's a meme, and you're committing sophistry.
Right. Okay.
Right?
By saying that,
Everybody
okay,
does
fair
not
enough,
know
Charles.
the Earth is an
Right,
oblate
okay.
spheroid.
Right, can we get back to this horizontal vertical relationship of the tool? Right?
Yes.
How do we know a tool can measure horizontal angles and vertical angles?
If it's set up properly.
Okay. So
It
we
should
set
have
it
no
up.
trouble.
We set it up on the horizontal plane, the azimuth, we set everything up. Right?
Azimuthal
Whenever you've got
plane,
a
yeah.
telescope or anything, it's set up on the azimuthal plane. Yes? And that way we know that when we move the telescope in the vertical position, it measures a vertical angle.
So in terms of telescopes, that's called an alt-az mount, as opposed to an equatorial mount.
Right. Well, that's what you have
Azimuthal.
with these
It's
tools.
an altitude azimuth, right? Alt-az, altitude azimuth. That's what
It's
you
a
do with a big
azimuth.
heavy telescope.
right.
With a
That's-
lighter
well, that's exactly the
telescope,
same as an auto
use
level,
a EQ
and
mount.
that's exactly the same as a telescope, right? And exactly
Okay.
the same as a theodolite. So now
Okay.
you're a little bit wiser on how the tools get set up.
If you handed me a theodolite, I probably would not set it up correctly. But it is possible that I might be getting
you
a
have to
theodolite in the near
actually
future.
have practice in doing that, setting it up. Right,
Yes.
but that's not
Okay.
what we're saying.
Yes.
We're talking about
Okay.
the principles of how they work.
Yes.
Right.
Sound geometric principles, yes.
Okay,
Measuring
so-
angles on the horizontal and vertical, yes.
Okay, so that's what Buster's talking about. So there's no need for you to now say that you've never done it, so you don't know. We're talking about the mathematical principles of horizontal and vertical, and I know for a fact, Charles, that you have a problem with perpendicular.
You're lying, because I have no problem with perpendicularity.
Okay,
What's he lying about?
You just said I have a problem with perpendicularity,
you
and
do.
that is the opposite of the truth. I
Betty's-
literally wrote a comment to you today. I have
Betty's-
no problem with perpendicularity.
Okay, so Betty's
For you to say I have a problem with perpendicularity
proof
is a lie.
of what we just went over with north, south, east, west, you curved one of the lines.
The line of latitude is curved.
Right, so that can't be perpendicular then, can it?
Only if you use the try-thinking on the level definition of perpendicular,
No,
which is not
no,
the,
no.
the,
We're
the
using-
definition the rest of the world
we're
uses.
using see, what's that?
This is projection.
That's
because,
a definition. He thinks that we're the only people that use the Euclidean definition of perpendicular.
Yes, and that's dishonesty. He accused you about dishonesty, and now he is blatantly dishonest.
But I'm pretty sure, right? We've been talking about it quite a lot recently. This is model affliction. He's lived in an arena where people have affirmed what he says. There will be people now patting him on the back for saying this, because it's necessary. It has to be like this, right? In order for the dogmatic globe to exist, these contradictions need to be spoken of. At some point, that somebody would have had to have come to this conclusion. I consider it. I don't know where. I say it's strange, but it's not really that. Other people haven't noticed this. They've skirted around this very blatant fact. It's right in your face, and if you can't see it just yet, it might come as a surprise when you do see it, because it's that simple. Perpendicular, a straight line, is all you need to understand. If you take on a concept of a model that says that you're going to contradict yourself the moment you start talking about straight lines, then you're going to struggle mentally on how to carry on. It's bad. It's bad.
Yes, they want this curvy perpendicularity for their model, but their problem is that it is impossible. There is only one instance where when you can have perpendicularity, you need two straight lines in only one orientation relationship.
Well, they're on a plane, aren't they? They have to be. Both of the lines have to exist within a plane, and the angle has to be within the plane.
Yes, absolutely. Yes. But still, it is only one relationship between two lines, straight lines, that can give you perpendicularity. You cannot produce any other example of perpendicularity if you don't have two straight lines. It is just impossible. And with two straight lines, there is only one instance when you can have it. So these two straight lines have to be in certain orientation to each other. Only one orientation. Maybe not orientation, relationship to with an angle.
Yeah,
So
because when you extend both of those lines, you make 4 angles that are all equal.
Yes, yes, yes. But I'm talking about this one example, because you cannot produce perpendicularity either way with the straight lines. So this is only one instance with straight lines. But without straight lines, you cannot even produce this one particular instance. It is just impossible.
Yeah, so
there
you
is-
would say that perpendicular is exclusive to Euclidean geometry. It doesn't exist.
Yeah.
It cannot
Yeah.
exist in other
Absolutely.
geometries.
Absolutely.
Yeah.
Yeah.
Yeah, I would be the same. The straight line is Euclidean, and the straight line is necessary for a right angle, a perpendicular. Therefore, only exists within Euclidean geometry, which is the geometry of the straight line. Straight line. I think this is where it starts getting a little bit fun from here on in. Definition from Euclid.
Euclid
That's the definition that we use.
Euclid. Okay, that's not a definition.
Yes, it is.
Euclid described.
It's a definition. The definition 10 in book 1, definition 10, he states, isn't a definition. Charles, geometry expert.
Geometry, yeah.
Yeah. Expert in geometry. Claimed to be a teacher. The state of teachings today. Number 10. Book 1. Do you want me to get it? I'll get it for you, right? You're saying it's not a definition because you
remember when Blue Marble Science said dead cats don't make sounds, dead dogs don't make sounds, therefore dead cats are the same as dead dogs, right? That's what he was talking about. If you have two straight lines crossing each other and it makes a right angle, that is called a perpendicular. That does not say that you cannot repeat that procedure with a curve and a straight line, or with a curve and a curve. There is nothing in that definition that is
perpendicular. So, let me get this straight, right? When a definition positively states something, the fact that it doesn't not state many other things that it doesn't means that you can just imagine whatever you want.
No, this is not what definition is, especially in science and especially in mathematics. Definition is exclusive, so you cannot apply definition to other things if it is not stated that it is, let's say, allowed to do that, because you don't know if you are using this definition in other cases in proper way, because maybe it cannot apply. So definition is exclusive. So if it is a straight line, it means that it is only straight line. So in definition, we have when a straight line, etc., it means that it is about straight line only. You cannot assume that he maybe was talking about also about curved lines. No. This is not how definition is created.
Well, especially
Only
within Euclid, because it's a step-by-step, it's an axiomated system. So every step builds upon the last. So he's not talked about curves. So you can't imagine a curve in here because there is none stated. Within the definitions, it's not even got there yet. Circle comes a little bit later. It's just building upon the straight line on the plane. To imagine something else in there is, well, that's a fallacy.
Yeah, yeah.
And I'd say this is a case of special pleading. The fact that it doesn't state something there is a special case that he thinks he can just add in something
I wouldn't say that this is special pleading because you are making a, let's say, exemption, or, but that would be a not allowed extension. He is extending. So from strict definition, he is making more general statement than it is. It is not general statement about lines. It is only about straight lines.
Yeah.
You cannot generalize. So
Yeah,
I would say that
because it doesn't say, and you can't have curved lines. It does. It states that they are straight.
Yeah.
In saying that, like, he's adding in this special case that he wants to add back in again, because he's saying that it doesn't say it where it does say it. It says the straight lines are called perpendicular. It's like, to me, I would say this definition is the definition for perpendicular, because it states what they call perpendicular within the, you know, like the definition. So you don't need to keep saying all of this that it says here. You can just say perpendicular, and that brings up all of the understanding of what perpendicular is.
Yes, and by the way, in this definition, perpendicularity is established by straight line standing on another straight line. So implying that straight line is standing, for example, on curved line, from that definition, that would give you a perpendicularity is just not allowed. This is illicit completely, because you cannot make that extension from that definition. That would also apply to a curved line. No, it is strictly in definition that straight line standing on another straight line. If it would be not about only straight lines, that would be just a line, not straight line. But it is said here that straight line standing on another straight line. So it is not line standing on another line, or straight line standing on another line, not straight. It is straight, 2 times straight line, for a reason.
Yep. So again, this is his name is Flat Earth Math. So sort of to be expected that this man has a troubled mind. He's called himself Flat Earth Math. He did that.
That is not the definition of perpendicular. That is identifying.
That's what it says. The other is called a perpendicular.
So show me where in that definition it says that nothing else can be called a perpendicular.
Wait a minute.
It's not there.
Two curves meeting.
Yes.
What is that?
They meet at an angle. The angle can be measured.
What's
you
an
add
angle?
Up all four angles.
Wait. You say
360.
two curves meet at an angle. What is your definition of an angle?
The orientation of where one line or segment, I'm trying to be careful with my language, meets another line or segment, line or curve, right? It's an orientation of where the two meet. You can have acute, you can have right angles, you can have obtuse, you can have all sorts of angles, but you will get, if you have two lines or curves, or one line and one curve, doesn't matter, they cross each other, it forms 4 angles. Those 4 angles will add up to 360 degrees. And that's where you get the joke of the tiny protractor. If you don't know what the angle is, you're not using a small enough protractor. That's the
Plane
joke.
rectilinear angle is the inclination of 2 straight lines to one another, which meet together but are not in the same straight line.
Yeah, so why don't we not call it a plane rectilinear angle?
Well, that's the definition.
We just call it an angle.
Sorry, Charles.
What the hell thing we
what do you want me to do?
Oh, notice the
Is it
phrase
upsetting to
rectilinear.
you? Is that upsetting
No, it's
to
not.
you that it's
Didn't you just say plane rectilinear?
Yeah, that's the definition, Charles.
Okay, of a plane rectilinear angle. How about we have a definition of an angle between a curve and a straight line, or an angle
about
between
you
a
do
curve and
that?
a curve?
Like, you think you can
Sure.
do that?
Oh, Euclid lived 2,500 years ago. And the amazing thing to me is that some people, I'm not naming names, but some people think that geometry stopped development when Euclid died. There has been no development in geometry in 2,500 years.
Who's that?
I will say Euclid
Who's
was a
that,
giant.
Charles?
Euclid was a giant. I'm not naming names.
Who thinks there've been no changes? Is it changes in geometry or
I'm saying
developments?
Developments, advances. For example, Euclid lived about 2,000 years before calculus, right? And guess what? Calculus, every calculus
Is
book
calculus
I've seen.
geometry, Charles?
Okay. Here, I'm pulling off my calculus
Charles,
book.
is calculus geometry, Charles?
It uses geometry extensively. The title of every calculus book I've seen is called Calculus and Analytic Geometry. Okay, it is literally in the title of every calculus book I've ever seen. Calculus and Analytic Geometry. Okay. And guess what?
Does
Calculus
that
was invented
redefine
2,000 years after
Charles?
Euclid.
Does that
Sorry?
redefine perpendicular?
Does not redefine perpendicular.
Okay. Well, so
Nothing in
it
definition
still
10.
stands then, right?
Definition 10 is not exclusive. There is nothing in definition 10 that says you cannot apply the word perpendicular to any other situation.
It's only the foundations of geometry, but I mean, hey,
So,
like you've got got a different definition somewhere. I suppose.
All right. I'm gonna challenge you, Bev, and you're not gonna like this very much. So you're gonna play along for a few moments. You're looking at definition 10. It's on my screen, the one you posted in chat. You looking at that?
Uh-huh. I posted it.
Okay. So, Bev, would you agree that you can have a plane perpendicular to another plane?
Absolutely. Definition
Well, according to
3,
definition 10, you can't.
No, definition 3, book 11,
No.
I think.
Just saying. If
Plane.
we're looking at definition 10, and it says nothing about a plane being perpendicular
because
to another
this is
plane.
book 1, Charles.
All I'm saying, Bev,
Book 11,
there
you want
is
to be
nothing,
looking at if a plane
Bev,
perpendicular to a plane.
Bev, you can't stop talking over. All I'm saying is there's nothing in definition 10.
Yeah, but I'm just pointing out to you,
that
Charles.
is exclusive.
This is the first bit of geometry, the conceptual part. You want to be looking at book 11. Solid
Bev,
geometry
you
for
were
a
holding,
plane perpendicular to a plane.
You were holding, Bev, you were holding a definition 10 as the definition of perpendicular, yet it doesn't make any mention of planes. My point, Bev,
No, it doesn't need
is that you can
perpendicular
extend,
isn't, Charles, is it?
You can extend the definition of perpendicular
is the
line.
relationship of a straight line to another straight line.
Yes, but not to a plane.
Yeah, but
not to a plane
you
to
can
another
have
plane,
those straight
apparently.
lines within planes, can't you? You
Doesn't say anything about a straight line within planes.
Charles, you can have both of them in the same plane, or you could have them both in different planes. And have
Where does it
the
say that in
planes
definition 10?
perpendicular.
You're just making this stuff up. Doesn't say any of that in definition 10.
I thought geometry was like a stair step.
So, can I just point out here that this guy is a claimed geometry expert, and he's asking why there is no definition of a plane and perpendicular to another plane within plane geometry, the book 1. And I'm telling him that the definition of a plane perpendicular to a plane is in book 11, solid geometry, obviously, because you need the third dimension to put the other plane in. And I don't know, like, what's going on? There's something wrong with his mind. Obviously, he is a mathematician, supposedly geometry expert. I mean, it's shocking.
Is it not a stair step process?
It is, and you guys stopped the stair steps 2,500 years ago.
Sorry, definition 4.
It's stair steps.
You guys
to where it's proof on proof on proof. And
Absolutely.
oh wait. Oh yeah. Okay. You say absolutely, but if you stair step, proof on proof on proof on proof, and you want to stop at step 3 and say, doesn't say this. Well, you just haven't gone to 3, 4, 5, 6.
So Buster, I hope you know, I was teasing Bev when I said it said nothing about planes. I agree that planes can be perpendicular. I'm teasing Bev because Bev was holding up definition 10 as the definition.
Are you all right, Charles?
I am perfectly sane and happy and whatever. Okay.
Like, your teasing is ridiculous because it's not really teasing. You're just making yourself look fucking ridiculous. It's like you don't even know about book 11.
Says you. No, I am not a Euclid expert. I know
Obviously.
extensive amounts of geometry, but I'm not a Euclid expert. Because guess what? Euclid died 2,500 years ago. Okay,
yeah.
and
that's
when I was
your
teaching
definitions and your understandings.
When I was teaching high school geometry,
book 11, definition 4. A plane is perpendicular to a plane when the straight lines drawn in one of the planes perpendicular to the common section of the two planes are perpendicular to the other plane. See, it defines it there for you. Like,
okay, so thank you for looking that up. But
yeah.
Bev, I hope you understand my point. Is
you were
that
teasing
the definition?
Me. I understand that you were childish teasing when you didn't understand the basic concepts of geometry, Charles. It's rather embarrassing for somebody claiming to be an expert in it.
What's very telling is the fact that you can't let me finish a sentence without talking right over because you know exactly what I'm going to say. But that's okay, Bev. This is your show. This is your forum.
Say, Charles.
You just won't let me say it. It's all good. Hey, I've been here over an hour. I really appreciate the hospitality. And Buster, it was good to speak to you again.
Yeah.
I hope to get my hands on a theodolite in the near future, maybe in a matter of months. So
okay,
I hope to learn how to use it.
If you do, just learn how to set it up properly. The whole crux of it was sighting to a plumb bob string after setting up properly.
Yeah. Well, I'll have to learn the ins and outs of that because like I said, I know more about the mechanics of a auto level than I do a byte. So
well, let's take an auto. Wait. Hang on, just real quick. You got an auto level. It's got a crosshair. You'd say it's set up properly. The crosshair in it is
right. The auto level. It's on a pendulum. The crosshair is in a little pendulum prism.
Yep. Perfect. What if you sighted to a plumb bob string?
Oh, meaning but the furthest plumb bob string you'd be able to sight is no bigger than a building site, so you're not going to have any problem there.
It would line up perfect.
Yeah, it would line up perfect. I mean, even if you could sight it in a plumb bob that's 69 miles away, the only thing you would see is it leaning away from you, and you would not be able to detect it leaning away.
Leaning away.
Yes. Because plumb bobs diverge 1 degree per 69 miles.
What if you set one up and I've got one just like you and I set it up properly, but I sight to the same plumb bob?
Yeah, it'll appear oriented properly vertically in both of our sites. I'm just saying because the auto level, even if you gave it a
what about if I do one as well?
It will look fine to all of us because the auto level, the crosshair on the auto level, of the vertical. I'm assuming it's got a vertical crosshair.
Away from someone.
Right, leaning right, and you cannot detect leaning away with a crosshair on an auto level.
What about if somebody else is looking at it? Would they not be able to see it leaning away?
It would not be able to. It won't. It would be leaning away equally for all people who are equidistant from that auto level or from that plumb bob. And you wouldn't be able to detect it. Yes, because any instrument would share a vertical plane with that plumb.
Don't you?
It just sucked over my answer. Yeah. Any instrument is sharing the same vertical plane as that plumb bob.
Okay.
And if you have,
even if we're
50
perpendicular,
people.
like if I'm perpendicular to you and Buster's perpendicular to me, and we're all looking at the same
plumb bob.
Yeah.
Yes.
And we're all perpendicular to the plumb bob.
I don't know how you'd be perpendicular to the plumb bob, but what I'm saying is, let's say you, Buster, and I were all 70 miles away, let's say 70 miles away from this plumb bob, and somehow we had a 10,000 power telescope on our auto level.
Okay. Well,
we would not
just
be able
you
to
and Buster,
detect it
right?
leaning away.
Let's say you are looking at your plumb bob, right? Yeah.
Yes.
Now
yes.
you say it's leaning away from you.
At the degree of 1 degree per 69 miles.
Okay, like we had
That's
that
the
before.
that's what
I've
people
already
joke
done a
about
meme of
lean
that.
away.
Right. Okay.
There's like a meme
what
about
then?
buildings leaning
What about
away
if
and
we
stuff.
send Buster perpendicular and him
Doesn't matter.
to look at the plumb bob that's leaning away from you?
It's also leaning away from him because the Earth is a globe. So no matter
it's
what
leaning
direction you go,
perpendicularly to each of you.
well, no, not perpendicularly. Any auto level.
Well, it must
Any
be.
auto
If it's
level
leaning
and
away
the-
from Buster and it's leaning away from you, and you and Buster are both perpendicular to the
Right,
plumb
like say
bob,
one's
then it
north
must
and
be
one's
leaning
east.
perpendicularly to itself.
No,
Yeah, it has to
Is-
be logically. Critical
No.
thinking, Charles. Switch it on.
no.
Come on.
What you're assuming? See, you've got model affliction. You're assuming that we're standing on a flat baseline, and we are
No,
not.
I'm assuming
standing on a
you're
curved
looking
baseline.
at a plumb bob.
Yes,
This is
but I'm
reality.
looking
Okay,
at
and
it
then
on a
I'm
globe.
sending Buster to perpendicular to the plumb bob, right? Because that obviously, if you can see the plumb bob, then there's a straight line from you to the plumb bob. So
And
we
let's say I
can
was
have
69 miles away.
perpendicular, right, to that plumb bob
Let's
from
say I
that
was due
line that
east.
you've got, and we could send
Right.
Buster to that position.
Let's see, was due south, right? I'm due east of the plumb bob. He's due south of the plumb bob.
Like
and
we
we're
had
both 69 miles
perpendicular
away.
before, but didn't you curve one of those earlier?
Let's just talk about what we're talking
So
about
I mean,
right
no,
now.
we need to know: do we have the same understanding of perpendicular, or are you going to edge in a
North.
curve somewhere?
North is perpendicular to east. Okay.
Okay,
So if I go,
but you're not going to bend east-west, are you?
I am not bending east-west.
Right. So east-west does not bend in this scenario when
Well,
we've got
no.
plumb bobs.
So, all right. Let's say you're starting at the plumb bob. And you have a.
Just have a
You
straight
could say
line
a
to
compass.
the plumb bob. Doesn't
You can
matter.
have a compass.
So you don't need
You
to
can point.
orientate it at all, right? You're
No,
just
you-
looking at the plumb bob.
but
There's a straight line
okay.
from you to
Literally
the plumb bob.
interrupted when I was trying to explain after you asked me a direct question.
Yeah, because you're
So
going to
can I-
start
can I
fucking
continue?
about with orientations. I was just
You
asking
wanted
you
a 90
whether
degree.
you have a problem with
You
perpendicular.
wanted a 90-degree orientation, did you not?
Perpendicular, yes.
Okay. So if you're at the plumb bob and you point your finger due east and you say, Charles goes 69 miles in that direction, and I go 69 miles in that direction. And then you point your finger due south and you say, Buster, 69 miles in that direction.
Uh-huh.
Are we agreed that that is a 90-degree angle? Okay. And we are
Well,
both
but you
69 miles away
pointing.
from the plumb bob. Sorry?
Are you pointing?
No. You were standing at the plumb bob, pointing east and pointing south. And so I travel east 69 miles, and Buster travels south 69 miles,
Okay,
making
that's because
a
we
right
know
angle.
that north, south, and east-west are perpendicular.
North, south, east, west are perpendicular. Yes.
So now
Are,
we've got
are we
a plumb
now?
bob.
Are we now established?
Yeah,
and now we're
now
looking
we
at this
understand. You're
plumb
both
bob.
looking at the same plumb bob.
Plumb bob. And
Yeah.
what I'm saying is the plumb bob string will
Yeah.
be leaning away from Buster at 1 degree. It will be leaning away from me at 1 degree.
Right, so
I'll also
but you
be
can't
aligned
notice the
vertically.
sideways tilt
It's
of it.
0 deviation sideways.
Okay, so are
Right?
you
0 deviation sideways.
Are you going sideways 1 degree then?
I am not going sideways. I've
How
got an
come-
auto
How
level that
come
has a
you
vertical.
can't see the tilt of Buster's plumb bob, and
Because we're
Buster can't
standing
see
on
the
a
tilt
globe.
of your plumb bob?
Because we're standing on a globe.
Well,
and so the plumb
Okay, well
bob,
that makes sense, right? It's a nonsense, right? That obviously makes sense. That's obviously Tis globe. That's a proof.
that's, you've
right
got
there.
you've got
Thank you
model
very
affliction
much.
there, Bev.
No,
got model
that is
affliction. You can't
that's
see
a
it.
proof from you.
Can't
Thank
you
you.
can't see it because you've got this model in your mind that it's not globe.
No,
Right?
no, I just said it has to be globe, right?
That Tis globe is a meme, okay, and it's a sophistry meme.
Yeah, but you've just
But
proved
if-
it is globe, right?
Okay.
You can't see the tilt of Buster's plumb bob, and Buster can't see the
No,
tilt of
your
your
plumb
plumb
bob.
bob.
No. Buster and I do not have plumb bobs. You have the plumb bob, and both of us are 16 miles away from it. One's east, one's south.
Uh-huh.
Okay. the vertical orientation of me and my auto level is the same as the vertical plane that is in the plumb bob is in. Likewise, Buster has a vertical plane that is passing through him and his instrument. It also is passing through that plumb bob, right? Neither of us can see the tilt of the plumb bob. It's directly leaning away from us. It doesn't deviate left or right. It is tilting away from us exactly at 1 degree per 69 miles. And that is how celestial navigation works. It's every degree of angle of elevation equals 69 miles of distance, or 60 nautical miles if you're on the ocean.
Man, you made
it only works. It only works if you're on a oblate spheroid.
His globe.
Oblate spheroid.
It's the only way it could happen, right?
Oh, I think Askin is upset that J-Ro invited me.
Yeah.
Anyway, so I don't want to monopolize your time. Thank you for the invitation, J-Ro. I really appreciate the conversation. Buster, appreciate it. Bev,
yeah.
Thanks for hosting. And I'm hoping to get my hands on a theodolite in the next, like, say, 2 months or so.
You should see how far you can actually see with it. What sort of angle you can measure over a certain distance.
Yeah, you definitely can't see 69 miles, at least to a plumb bob, but it's always great.
What you should do is just check it over about 500 meters and see how accurate you can see the angle measurement.
Yeah, that'll be interesting.
Yeah.
All right, gentlemen, thank you very much. I hope you guys have a great evening and a great weekend. Oh, today's Friday. Yeah, hope you guys have a great weekend.
Yeah. Okay.
Right, take care. Bye-bye.
See ya. Oh, it's 4:15. I'm gonna have to leave it there. That's the end of that. No, you don't want to hear the after conversation there. If you do want to listen to it, pop into Discord. That's where these conversations occur. Charles has been into Discord. He's gone to a birthday party, so he's okay. He'll be all right. And I see Bob's back in the chat. Welcome, Bob. Good to see you around. He's got plenty. He's got loads of accounts, like, these people that have multiple accounts. He has ones for his cats and his cat's webcams. It's quite nice, really, isn't it? Oh, and the poll. What do we get for that one? Oh, 79%. So there's a lot more people that think that horizontal and vertical are perpendicular than latitude and longitude. I mean, we should have like a table of perpendiculars and to see what people imagine. Which is the most perpendicular, I think. Can you think of which would be the most perpendicular thing, whether it's either plumb and level or horizontal or vertical, latitude and longitude, north, south, east, west? Because I think we are going to be talking a lot about these perpendicular relationship. It seems to be one of the easiest ways to have a conversation about the mind and how the mind reacts to these things. There's a lot of ECV in the air whenever we're talking about a basic thing like perpendicular. People just, their minds wander to other things, and the beauty, well, I say the beauty, the concept of this arena that we're in, people are always swapping and changing conversations and arguments, and there are people that are willing to go along with these swapping and changing, and that's the mind reacting, trying to get away from addressing the actual issue that we're talking about. So yeah, I'd say to Paige in the chat, it's not about winning or losing. This is about how the mind comprehends information, takes it in. There is no winning or losing. There's no winning or losing in a debate. There's only the acquisition of more knowledge, learning how to talk to people. I don't like the idea of laughing at people and doing all of that. I think that we're better off if we can communicate, and I don't think that's the sort of way to go forward. I'd encourage conversation with anyone. I'm not too keen on the round and round, allowing people to be distracted. Please don't discourage the Asperger's sort of thing. Iridium, not liked. As I say, I'm going to be going over. My kitchen's getting done this week, so I don't know what's going to happen, but probably we're going to be doing the same as we did last week for a couple of weeks. I might come out. I've got a couple of videos I might put out during the week, but I don't think we're going to be going live. Probably come back Friday, I think, at the end of the week. I'll try and put a couple of videos out, give people something to go over. I might put this video out of our conversation with Charles so people can listen to the lengths that people have to go to disregard basic geometry. Let me just get a Buster song. What do you reckon? Another, like the Buster, Who Will, I think I've not. Okay, we're going to end up with Buster, Who Will, because I think this sums us up at the minute. Thanks for watching. We'll be back Friday, but all week in Discord. If you want to come on in, particularly around this sort of time, we'll be doing something we always do. See you Friday.
Yeah, see you on there. I see the writing on the wall, it's plain. Ramblings of his madman going insane. And now I see it clear. They're running and they're hiding because of fear.
I don't sing, if I don't speak out, if I never receive the Logos who transcendental numbers and conceptual maths will take you on a journey down a Penrose path, and you'll never see it clear. The path that you're on begins in tears. If I don't sing and if I don't speak out, if I never communicate with logic or will, if I don't sing and if I don't speak out, if I never receive the Logos or will. Cast away the shadows and step into light, taking down giants and opening sight. And now I see it clear, the path that you're